Hello there, and welcome to the Drift to the Stars. I'm so glad you found your way here tonight. Wherever you are right now, tucked in, stretched out, eyes already growing heavy, you've arrived somewhere gentle. This is a place for curiosity without urgency, for questions that don't demand answers, for the kind of wonder that feels less like excitement and more like a long, slow exhale. We're going to spend some time tonight with one of the oldest and strangest companions you've ever had. Not a person, not a place, time itself. The thing that carries every moment you've ever lived, that runs through the stars and through your bloodstream, that bends and stretches in ways that still quietly astonish the people who've spent their whole lives studying it. And just before we begin, if these calm, curious explorations help you unwind, consider liking and subscribing to the channel. It helps others find their way here too, one sleepy soul at a time. Now, if you're ready, let's begin. There is something you've lived inside every moment of your life, something so close and so constant that you've never once had to think about it. And yet the universe treats it as one of its most flexible, most surprising, most quietly radical inventions. You feel it as a steady current, a river moving in one direction, carrying mornings into afternoons, into the soft arrival of nights like this one. You feel it in the way a candle burns down, in the way faces change in photographs, in the way you remember yesterday but cannot touch tomorrow. But the universe, it turns out, does not experience time the way you do. Time, for the cosmos, is something closer to clay than to current. It bends, it stretches, it slows and quickens depending on where you stand, how fast you move, how deep a gravity well curves the space beneath your feet. This is not a story. It is not a metaphor. It is the measured, confirmed, tested truth of the world you live in. And it is, in its own quiet way, one of the most beautiful things anyone has ever discovered. Time is not a constant river. It is something far stranger and far more personal than that. The fact resting underneath all of this is simple enough to say in one breath, though it takes a lifetime to fully feel. Time is not fixed. It flows at different rates in different places throughout the universe, and those differences are real and measurable, and happening right now, all around you, even as you rest here and let your body grow still. You are not watching the universe from outside. You are inside time, the way a fish is inside water. And the water, it turns out, runs faster in some places and slower in others, and the fish never quite notices the difference. There is a place in the universe so massive, so dense, so gravitationally absolute, that time near its edge does something almost impossible to hold in the mind. Imagine you had a clock, not a digital one, not a watch, just a simple, steady, faithful clock. The kind that ticks once per second, reliably, the way a heartbeat does when you're calm and lying still. Now imagine lowering that clock toward a black hole, not dropping it, lowering it, slowly, carefully, the way you might lower a lantern into a deep well to see how far down the water sits. As the clock descends, something begins to happen. Not to the clock itself. From the clock's own perspective, everything continues normally. It ticks, time passes, nothing feels wrong. But from where you stand, watching from a safe distance, the ticks begin to slow. 1 per second becomes 1 every 2 seconds, then every 10, then every 100. The closer the clock drifts to the event horizon, that boundary of no return, the slower time moves for it relative to you. And in the extreme limit, as it approaches the edge, time for that clock appears to stop entirely. A single second near a black hole lasts far longer than a second in open space. Not because the clock is broken, because time itself is moving differently there. Because gravity does not only pull matter, it pulls moments. Something in the universe arranged for time to be a living, responsive thing rather than a rigid rail. And that arrangement holds in every corner of the cosmos, quietly, without announcement. Right now, somewhere above you, moving in a clean arc across the dark, there are satellites. Small, precise, dedicated machines tracing paths around the Earth, sending signals downward that help a phone tell you where you are, help a pilot land a plane, help a ship find its way across open water. These satellites carry clocks, extraordinarily accurate clocks, calibrated to a precision that would have seemed like fantasy a century ago. And those clocks, every single day, run fast. Not because of a flaw in their engineering, not because of interference or error. They run fast because they are further from the center of the Earth than you are. They sit higher in the gravitational field. And because gravity bends time, and they experience slightly less gravity than the clocks on the ground below, time moves very slightly quicker for them. If engineers didn't correct for this difference, GPS systems would drift by kilometers every single day. The correction is built in, invisibly, so seamlessly that most people never know it's there. The clocks aboard GPS satellites run measurably faster than clocks on the ground beneath them. And this fact is not a curiosity tucked into a physics textbook. It is quietly embedded in every navigation system on the planet, working in the background the way a heartbeat works, unannounced, keeping everything on course. The strangeness of the universe is not always in the sky. Sometimes it is in the small, bright rectangle in your pocket, bending time so gently you never feel a thing. There is one thing in the universe that never slows down, one thing that holds its speed with an absolute, unbending, almost stubborn constancy, regardless of where it travels, how far it goes, or who is watching it. Light. Across empty space, light always moves at the same speed. Not approximately the same, exactly the same. Whether the source is rushing toward you or retreating from you at tremendous speed, the light it releases arrives at your eyes, traveling at precisely the same velocity. This seems simple. It is, in fact, the edge of a cliff. Because if the speed of light never changes, and if you start to move faster and faster yourself, something else has to give way. Something has to absorb the difference between your motion and light's unwavering pace. That something is time. Light always travels at the same speed, and that unchanging, uncompromising, absolute constancy is what makes time itself flexible. Time is not the bedrock. The speed of light is the bedrock, and time is what bends so that the bedrock can stay firm. It is one of the quietest revolutions in the history of human thought, that in trying to understand light, we discovered that time was not what we imagined, that the universe would rather stretch a moment than let a photon slow down. There is something almost tender about that. The cosmos holding one thing constant at the cost of everything else's rigidity, keeping that one promise forever in every direction. You have climbed a mountain, perhaps, or stood on a tall building and looked out over a city laid flat below, or simply taken an elevator to a high floor and felt the slight shift in the air as the doors opened. In any of those moments, something was happening that you had no instrument to detect, no sensation to confirm, and no particular reason to suspect. You were aging faster, only by a tiny, almost laughably small amount. A difference so minuscule, it would take equipment more sensitive than anything you could hold in your hands to verify it. But real, measured, confirmed. The higher you are above sea level, the weaker Earth's gravitational pull on you, and the less gravity bends the local flow of time. So at altitude, time flows very slightly faster than it does at sea level. And so you, standing on a mountaintop, move through your life at a pace that is, by the narrowest sliver, quicker than someone resting in a valley below. You age more slowly at sea level than you do on a mountaintop. Not in any way you would feel. Not in any way that would change a single thing about your morning. But the universe knows the difference, even when you don't. There is something gently leveling about this. The mountain does not make you grander or more significant. It simply places you in a slightly different stream of time. And the stream, indifferent and ancient, flows on regardless. Before the equations, before the telescopes, before the satellites carrying their corrected clocks through the sky, there was a young man sitting quietly with an idea. He was not in a laboratory, He had no instrument in his hands. He was simply thinking, the way a person thinks when they have learned to go very still inside a question and wait for it to answer itself. The question was this: what would it feel like to ride a beam of light? Not to follow it, not to watch it from behind, to sit astride it, moving with it at its speed, and look around at the universe from inside that journey. He noticed something troubling. If you traveled with a beam of light, the light beside you should appear frozen, still. But the laws of physics said light could not be still. Light was always moving, always at the same speed. And yet, from inside the beam, it seemed like it should stop. That contradiction, held patiently in the mind of a 26-year-old, eventually became the theory of special relativity. Einstein imagined all of this not with instruments, but by picturing himself riding a beam of light. Most of what we know about time's flexibility grew from that single quiet act of imagination, from a person sitting still and wondering what motion would feel like at its most extreme. You have done something like that yourself, perhaps, in the slow drift before sleep, followed a thought somewhere strange and dark and still. The universe has a way of rewarding that kind of patient wandering. You have touched a piece of fabric, a tablecloth, perhaps, pulled tight across a surface, or the skin of a drum, taut and responsive. Press your finger into it, and it gives. The material around your fingertip curves slightly downward, distorting the flat surface in all directions around the point of pressure. Now imagine that the fabric is not cotton or skin. Imagine it is everything, space in all three directions, and time running through it as a fourth, one woven thing. A single, continuous, four-dimensional cloth, extending in every direction, from the smallest corner of a room to the furthest edge of what has ever existed. This is space-time, not a metaphor invented to make physics friendlier, an actual description of the structure the universe is built from. Time and space are not two separate things. They are one woven fabric, and every massive object in the universe presses into it, curves it, shapes it the way your finger shapes a tablecloth. And everything moving through that fabric, including light, including planets, including you, follows those curves as naturally as water follows the shape of the ground beneath it. The universe is not a stage on which things happen. It is a thing that happens, bending and flexing, carrying time along with it. And you are not watching. You are woven in. When most people think of gravity, they picture a force, something invisible but real, reaching down from above, pressing you into the ground, keeping the moon locked in its long, quiet orbit. But gravity, in the deepest understanding we currently have, is not a force at all. It is a shape. Massive objects do not pull smaller ones toward them. They curve the fabric of space-time around themselves, and smaller objects simply follow the curve, the way a marble rolls toward the lowest point of a bowl, not because something is pulling it, but because the surface beneath it leans that way. And where the curve is deepest, where the fabric bends most sharply beneath the press of enormous mass, something else happens alongside the warping of space. Time slows. Gravity is not a force pulling things down. It is a curve in the fabric of space-time, and time flows slower where the curve is deepest. Not metaphorically, not approximately, exactly, measurably, verifiably slower. At the center of a massive planet, time ticks more slowly than at its surface. At the surface of a neutron star, more slowly still. At the edge of a black hole, the slowing becomes almost total. And on the surface of the Earth, at the bottom of a valley, in the lowest point of the deepest trench of the deepest ocean, time runs the tiniest fraction slower than it does for you. Here, in this quiet room, gravity is not just pulling at your body, it is tugging, ever so gently, at your moments. Somewhere, there is a number, approximately 13.8 billion years, and it represents something that human beings have been reaching toward since the first time anyone looked up at a dark sky and wondered how long any of this had been going on. The age of the universe. But here is where it grows strange, and gentle, and a little dizzying in the best possible way. That number is not a single, universal, absolute fact stamped into the cosmos the way a date is stamped into a coin. It depends on how and where you measure it. Because time flows at different rates in different places, and because the universe has been expanding since its first moment, and because the fabric of space-time has been stretching and curving and folding throughout its entire history, the age of the universe is a kind of average, a consensus, something agreed upon by observers who are all, in slightly different ways, experiencing different versions of time. The universe itself has an age, roughly 13.8 billion years, and that age depends on where and how you measure it. It is the best answer we have, and it is genuinely extraordinary, and it is also, in the most precise possible sense, a local estimate from a particular vantage point on a particular planet in a particular region of space. The universe is old, quietly, vastly, gently old, and you are here, at this specific moment in its long unfolding, which is a fact worth sitting with for a moment before sleep. There is a type of star so compressed, so collapsed under its own weight, that a single sugar cube-sized sample of its material would weigh as much as all the mountains on Earth combined. A neutron star. The gravity at its surface is so intense that the very concept of standing on it becomes a kind of thought experiment without a safe answer. Light bends visibly around it. Matter behaves in ways that test the outer edges of our physical understanding. And time, near its surface, does something that no clock built by human hands was ever designed to handle. Near the surface of a neutron star, 1 second takes the equivalent of years of time elsewhere. Not years as metaphor, years as a measurable discrepancy between a clock resting near that surface and a clock floating safely far away in open space. The one close to the star ticks with perfect mechanical obedience. 1 second, 2 seconds, 3. But from a distance, those 3 seconds have stretched across what would feel, from far away, like a very different span of time altogether. The star does not care. It burns and spins and slowly cools, indifferent to the time it bends around itself, the way a stone bends water in a stream. And somehow, knowing that something as dense and extreme as a neutron star exists in the same universe as a quiet bedroom and a person drifting towards sleep, makes the night feel very large and also very safe, the way a small lamp makes a large dark room feel inhabited and warm. There is a thought experiment so quietly devastating in its implications that physicists still use it decades after it was first proposed, not because it hasn't been answered, but because the answer itself is the strange and beautiful thing. Picture 2 people, brothers, perhaps, or sisters, born on the same day, raised in the same house, sharing the same memories of the same childhood mornings. They are, in every measurable sense, identical in age. One of them stays on Earth, in the familiar pull of ordinary gravity, moving through ordinary days at the ordinary pace that all of us move through our lives without noticing. The other travels, not far in the ordinary sense, but fast, faster than anything you have ever experienced, close to the speed of light, which is to say, close to the absolute limit the universe has placed on motion through space. When the traveler returns, something has happened that neither of them caused, neither of them chose, and neither of them can undo. They are no longer the same age. 2 twins, one staying on Earth and one traveling near the speed of light, would return to find themselves different ages, and both would be correct, not mistaken, not measuring differently, actually, physically, biologically different ages. The traveler has lived fewer moments, has had fewer heartbeats, has aged less, in the most literal cellular sense. Time did not play a trick on them. Time simply moved at the rate it always moves, which is to say, the rate that depends entirely on how fast you are moving through space. And in the stillness of this room, where you are moving very slowly through space, and therefore very steadily through time, every moment you rest here is, in its own way, the full and unhurried version of a second. At the center of the Milky Way, roughly 26,000 light-years from where you lie right now, there is a silence so profound it bends the galaxy around itself. Not an empty silence, a massive one. Sagittarius A Times is the name given to the supermassive black hole anchoring the center of our galaxy. Its mass is approximately 4 million times that of our Sun. Not 4 million suns laid end to end. 4 million suns compressed into a region of space smaller than the distance between our Sun and its nearest neighboring star. The gravity it generates is not something that can be felt from here, but it shapes everything. The orbits of stars near the galactic center trace tight, fast, elliptical paths around it, the way iron filings arrange themselves around a magnet, unable to resist the curvature it imposes on the space they move through. And time, near its edge, does what time always does near enormous mass. The Milky Way's central black hole is so massive that time near its edge creeps at a fraction of our pace. A clock placed near the event horizon of Sagittarius A Times would tick with perfect fidelity from its own perspective. But from here, from this quiet planet on a quiet arm of the galaxy, that clock would appear to move with a slowness that has no good comparison in ordinary life. The galaxy has a heart, and that heart bends time the way deep water bends light, the way sleep bends the felt length of a night, making some hours vast and some hours nothing at all. Look up on a clear night, if you can, or simply imagine it, here in the warmth behind closed eyes. The sky dark and wide, and spread across it, like flour dusted across a dark cloth, the soft, scattered light of stars too numerous to count individually. That light is old. Not old the way a photograph is old, or the way a building is old. Old in a way that stretches the word until it becomes something closer to geological, to astronomical, to a timescale the body cannot fully absorb, but the mind can quietly rest inside. Some of that light left its source before humans had language, before there were cities, or agriculture, or any of the things we have built in the thin layer of time we call history, before there were humans at all. And yet here it is, arriving tonight, completing a journey so long that the civilization capable of understanding the journey only appeared near its very end. But the oldest light of all is not starlight. It is something subtler, a faint, pervasive glow filling every direction of the sky equally, invisible to the naked eye, but mapped in extraordinary detail by dedicated instruments. The cosmic microwave background is time itself made visible, a faint echo of when the universe was only 380,000 years old. Before that moment, the universe was too hot and dense for light to travel freely. Then, in a kind of cosmic exhale, it cooled just enough, and light escaped. And that light, stretched and reddened by 13.8 billion years of expansion, is still traveling, still arriving, still filling the universe with the quietest possible record of its own earliest chapter. Every direction you face contains that signal, ancient beyond all ordinary language, still here. On Earth, sound needs something to move through. Air, water, wood, the bone of your skull. Set a vibration going in a vacuum, and it simply stops. There is nothing for it to push against, nothing to carry its compression forward into the next moment. Space is not empty, exactly, but it is too sparse, too thin, too spread across, too vast a distance for sound to travel through it in any meaningful way. The enormous explosions of dying stars, the collisions of galaxies, the jets of superheated matter fired from the poles of black holes, all of it happens in a silence that no human ear could survive long enough to notice. And yet, time moves through all of it, through the silence between galaxies, through the cold dark between stars, through the vast and quiet spaces where no particle has drifted in longer than civilization has existed. Sound cannot travel through space, but time can, and does, and moves through every corner of it, without exception, without diminishment, without needing a medium, or a carrier, or anything to push against. Time does not require matter to keep moving. It does not require warmth, or light, or the presence of anything at all. Even in the emptiest possible region of the universe, even in a void so complete it makes the word lonely seem inadequate, time continues, quietly, steadily, at whatever local rate gravity and motion dictate. You are never outside of time. There is no outside. There is only the vast interior of a universe, that time moves through the way breath moves through a sleeping body, without effort, without announcement, without end. There is a well, old, stone-lined, narrow, the kind that exists in the imagination as much as in any particular landscape. And at the top of this well, a clock, and at the bottom, another. Both clocks are precise. Both are kept in perfect condition. Both are measuring the same thing, the passage of 1 second into the next. And yet they do not agree. The clock at the bottom of the well sits closer to the Earth's center. The gravitational field is slightly stronger there. The fabric of space-time curves more sharply beneath it, and so time, for that clock, moves slightly slower than it does for the clock resting at the rim above it. A clock at the bottom of a deep well ticks slower than a clock at its rim, and this has been measured. Not imagined, not calculated only in theory, but placed in actual towers and actual shafts, and timed with actual instruments sensitive enough to detect a difference across a vertical distance of only a few meters, the height of a room, the length of a person lying down, a distance so ordinary that you cross it simply by standing up, and across that distance, time differs. This should perhaps be alarming. It is, instead, somehow deeply reassuring, in the way that all confirmed strangeness eventually becomes reassuring once you've rested inside it long enough. The universe is not pretending to be simpler than it is. It is genuinely, measurably, quietly extraordinary. And it has been this way the whole time, without needing you to notice. There is a trade at the heart of the universe that no one negotiated and no one can escape. It applies to everything that moves, to light, to planets, to satellites, to the slow drift of a leaf carried by wind, to the blood moving through your veins right now as you lie still. The trade is this: the faster you move through space, the slower you move through time. Not as a penalty, not as a cost, simply as the way the mathematics of a universe with a fixed speed of light must arrange itself to remain consistent. Motion and time are always in a kind of gentle trade. If you pour more of yourself into moving through space, the universe quietly reduces the rate at which you move through time. If you hold very still, as you are doing now, time moves through you at its fullest local pace. A particle accelerated to nearly the speed of light ages barely at all during its brief, blazing journey. A person sitting quietly in a room ages at the most generous rate their position in a gravitational field allows. Neither is more correct than the other. Both are experiencing time exactly as the universe intends, for something moving at their particular speed. And somewhere in that trade is something worth staying with, that your stillness right now is not absence. It is the fullest possible engagement with time. You are not missing anything by resting here. You are, in the most precise physical sense, receiving the most time you could possibly receive. Inside a laboratory, in a room kept cold and still, and sealed from any vibration that might disturb its extraordinary precision, there is a clock unlike any you have encountered in daily life. It does not have hands. It does not have numbers that flip. It does not tick in any way you could hear. What it has is an atom, and that atom, when struck by light of exactly the right frequency, vibrates, and it vibrates not approximately the same number of times per second each time. It vibrates exactly the same number of times per second, always, reliably, with a consistency that makes the most accurate pendulum clock in history look like a rough estimate scratched in sand. Atoms vibrate at astonishing regularity, and atomic clocks use that vibration to measure time more precisely than any pendulum ever could. So precisely that the best atomic clocks would neither gain nor lose 1 second across a period longer than the current age of the universe. We built these clocks to measure time, and what they revealed when we took them up mountains and sent them into orbit and compared them to clocks at rest on the ground was that time itself was not what we thought, that our clocks were working perfectly and time was the variable. There is something quietly moving about that. Human beings built the most precise instruments in history to measure something, and the instruments worked so well they proved that the thing being measured was stranger than the instrument's makers had imagined. Precision did not simplify the universe, it deepened it. Before there were stars, before there were atoms of the kind that make up everything you have ever touched, before there was space in the ordinary sense of a place that things could occupy and move through, there was a moment, or something like a moment. The language grows uncertain here at the edge of what can be known, and the uncertainty is not a failure. It is an honest map of where the known world ends and the genuinely open question begins. The universe began in a state of density and temperature so extreme that the ordinary rules governing matter, energy, space, and time did not apply in the ways they apply now. The equations we use to understand the physical world begin to break down when pushed back to that first instant, producing answers that are infinite or undefined or simply silent in a way that tells us we do not yet have the right framework to ask the question properly. The universe began in a moment so dense and hot that the ordinary rules of time may not have applied at all. Time as we experience it, time as a smooth flow from one moment to the next, may be something that emerged gradually as the universe expanded and cooled and allowed structure to form. In those first instants, time may not have been flowing anywhere in particular, or flowing in every direction, or not yet flowing in the sense we understand flowing. We do not know, and the not knowing is not unsettling tonight. It is spacious, a reminder that the universe has depths that remain genuinely open, genuinely waiting, genuinely patient with the pace of our understanding. Before the universe was a second old, a question arose that physics still approaches with something close to humility. Was there anything before this? Was there a before? The word itself becomes slippery at that edge. Before implies a time prior to the moment in question. But if time itself came into being at or near the beginning of the universe, then asking what came before is a little like asking what is north of the North Pole. The question uses the right words in an arrangement that the territory cannot support. Some physicists believe there was no before the Big Bang, that time itself was born in that first instant. Not that nothing existed before, but that the concept of before did not exist before. That time is not a container the Big Bang happened inside of, but something that arrived with the bang, or in its earliest moments, or gradually as the universe settled into a shape that permitted something like sequence to occur. This is not a comfortable idea, and it is not meant to be comfortable in the way an answer is comfortable. It is meant to be honest, to acknowledge that the edge of time is something we can approach, but perhaps never fully cross in understanding. And there is a particular kind of peace available in that acknowledgement. Not every question needs its borders dissolved tonight. Some questions are companions. They travel with you. They sit with you in the dark, and they make the dark feel less like an absence and more like an open room. Right now, the light reaching this planet from the sun is not telling you about the sun as it exists in this moment. It is telling you about the sun as it existed 8 minutes and 20 seconds ago. That is how long it takes light, moving at the only speed it knows, to cross the distance between the sun and the surface of the earth. So the warmth and brightness of a summer afternoon, the particular quality of afternoon light through a window, the way sunrise looks when it comes, all of it is a message that left its source before it arrived. All of it is, in the precise sense, history. The sun you see right now is the sun as it existed 8 minutes and 20 seconds ago. This is not a large delay in the context of your day. It does not change how the afternoon feels, or what the garden looks like, or the quality of the light on a particular evening. But it means that you have never seen the sun as it is, only as it was, only as a slightly aged version of itself, sending its light forward through time as well as space, reaching you exactly when the journey is complete. And knowing this does not diminish the light. If anything, it adds something. A sense that even the most ordinary, most daily, most taken-for-granted features of life are arriving from somewhere, carrying a journey inside them, moving through time to find you exactly here. The light knows where you are. It always arrives. Every astronomer who has ever pressed an eye to a lens, every physicist who has ever aimed an instrument at the dark, has been doing something that sounds simple and turns out to be profound beyond ordinary reckoning. They have been looking into the past, not metaphorically, not poetically, literally, physically, verifiably, into the past. Because light takes time to travel, and the universe is vast enough that the time light needs to cross it is measured not in minutes, but in millions, and in some cases, billions of years. The nearest large galaxy to our own, Andromeda, appears in the sky as a faint smudge visible to the naked eye on a clear, dark night. But the light forming that smudge left its source approximately 2.5 million years ago, before our species existed, before the particular configuration of the continents that we consider normal had fully settled into place. Looking deeper into space is identical to looking deeper into the past, and every telescope is also a time machine. Every image, captured by every observatory on Earth or in orbit, is an image of something that no longer exists, exactly as pictured. The universe has moved on. The light has simply been traveling. And perhaps the most tender version of this truth is the amateur astronomer, standing in a backyard on a cold, clear night, pointing a modest telescope at a distant cluster of stars, and seeing something that left its source before the first human city was built. Receiving it, being the end point of a journey that began before anyone was around to imagine the journey might one day be completed. The universe aimed its light at you long before you were here to receive it. Somewhere in the shoulder of the constellation Orion, visible on winter nights in the northern hemisphere, there hangs a star so large that if it were placed at the center of our solar system, its surface would extend past the orbit of Jupiter, Betelgeuse. It is old, in the way that only the most massive stars are old, which is to say, not particularly old in years, but exhausted in fuel in a way that smaller, steadier stars, like our Sun, will not be for billions of years yet. Betelgeuse is burning through itself quickly, brilliantly, extravagantly, and at some point, perhaps recently in astronomical terms, perhaps not for another 100,000 years, it will reach the end of that burning. It will collapse inward in a fraction of a second, and then explode outward in one of the most energetic events the universe produces, a supernova. Here is where time becomes strange, in the most personal possible way. Betelgeuse is approximately 700 light-years away, which means the light we see from it tonight left its surface 700 years ago, which means we have no knowledge of what Betelgeuse is doing right now, in this moment, because the information about right now will not reach us for another 700 years. Betelgeuse may already have exploded. The explosion may have happened centuries ago, and the light from that catastrophic, beautiful unraveling is simply still on its way. If Betelgeuse has already gone supernova, that explosion happened in a past that is still, from where you stand, the future. Time, across distance, stops being a shared experience and becomes something each location carries alone. Hold a thought for a moment. Not a complex one, just this. Every point in space has its own relationship with time. Your relationship with time is shaped by your position in Earth's gravitational field, your velocity through space as the planet orbits the Sun orbits the galactic center, and the galaxy moves through the local group. All of these motions are happening right now, quietly, without your participation being required. And at every other point in the universe, something similar is happening. Every planet, every star, every drifting grain of interstellar dust occupies a slightly different position in the gravitational landscape of the cosmos, and experiences time at a slightly different rate as a result. There is no place in the universe that stands outside all of this and observes it neutrally. No control room, no vantage point where time flows at the one true rate and everything else is measured against it. There is no universal now spread across the cosmos. Every point in space has its own present moment. Yours is here. Whoever or whatever might exist in a planetary system orbiting a star in a neighboring galaxy has a present moment too, but it is not the same present moment. The two present moments cannot be synchronized. They cannot even meaningfully compare notes. The present is not a single candle lighting everything at once. It is more like rainfall at night, each drop arriving in its own place, at its own time, belonging entirely to where it lands. And yours has landed here, quietly, right now, which is, in the only sense that truly matters, enough. There are particles created high in the atmosphere of the Earth, born in the collision between incoming cosmic rays and the molecules of air that form the thin skin of sky above your head. They are called muons. They are subatomic, fleeting, and by the standard accounting of physics, they should not exist long enough to reach the ground. They are created roughly 15 kilometers up, and they decay, on average, in about 2 millionths of a second. Even traveling at nearly the speed of light, the mathematics say they should vanish long before covering the distance to sea level. And yet they arrive, billions of them, every single day, passing through the roof above you and through the floor beneath you and through your own body without pause or ceremony or the slightest awareness of having crossed anything at all. They arrive because of time dilation, because at the speeds they travel, time slows for them. What is 2 millionths of a second in ordinary time becomes, from the muon's perspective, enough time to complete the journey. The muon does not experience itself as surviving against the odds. It simply experiences its own normal duration of existence, which is long enough because time has adjusted to accommodate its velocity. Muons survive long enough to reach Earth's surface only because time slows down for them as they travel, and this is verified daily by the simple fact of their arrival. You do not need a laboratory to confirm time dilation. You need only to know that muons exist at ground level when the math says they shouldn't. The universe is, in this sense, passing through you right now with proof of its own strangeness. Somewhere over your head, at this very moment, 6 people are living in a cylinder of metal and glass, moving at roughly 28,000 kilometers per hour around the Earth. The International Space Station. Those people wake and eat and work and sleep on a schedule calibrated to a day that doesn't quite match the one below. They see 16 sunrises every 24 hours. They float between tasks, their bodies slowly adapting to the absence of gravity's full pull, their bones and muscles gradually reminded that the architecture of a human being was built for Earth, and they age slightly differently. The station moves so fast that time dilation from velocity slows their clocks very slightly relative to the ground. At the same time, they are higher up, where gravity is weaker, which slightly speeds their clocks. The velocity effect is larger, so on balance, time moves just a little slower for them. Astronauts living aboard the International Space Station age about half a second less per year than people on the ground. Half a second. An amount so small that no human being could notice it from the inside. But it is real, measured, accumulated across long missions. The astronauts return to Earth having lived, in the most precise physical sense, ever so slightly fewer moments than the people who stayed behind. Their bodies know nothing of this. Their memories are continuous. Their sense of time uninterrupted. And yet, the universe kept meticulous account. There is a spacecraft right now, at this moment, traveling through interstellar space, past the heliopause, past the boundary where the sun's influence finally gives way to the wider dark between stars. Voyager 1. It was launched in 1977, which means it has been traveling for nearly 5 decades, carrying gold-plated records inscribed with sounds and images of Earth aimed at no particular destination, moving outward simply because there was nothing left to stop it. It is the most distant human-made object in history. The signal it sends back travels at the speed of light and still takes more than 22 hours to arrive. And because Voyager has been moving so fast for so long, something has happened to its experience of time that is small in magnitude but absolute in certainty. The Voyager 1 spacecraft has aged very slightly less than if it had stayed on Earth because of its speed. The difference is extraordinarily small, a fraction of a second across nearly 50 years of travel. But the mathematics are unambiguous, and there is something quietly beautiful about knowing that this small, faithful, gold-carrying machine is not only far away in space, it is also, by the tiniest of margins, slightly further back in time than it would have been had it stayed home. We sent a message into the universe, and time, in its gentle way, folded around it as it went. The Earth is not spinning today at quite the same rate it spun when the first living things pulled themselves from warm, ancient water toward whatever light reached them there. It is slower now, just slightly. The difference accumulated across hundreds of millions of years, a kind of cosmic patience applied to the most ordinary fact of daily life, the length of a day. The Earth's rotation is gradually slowing. Our days are growing imperceptibly longer with every passing century, not in any way you could feel across a human lifetime, or even across recorded history in any direct sense, but measurably, verifiably, confirmed by the fossil record, by ancient corals that recorded their daily growth rings, by the patient arithmetic of celestial mechanics. In the time of the dinosaurs, a day was roughly 23 hours. Further back, in the Cambrian, closer to 21. At the very beginning, when the young Earth was still cooling and the Moon was much closer than it is now, a day may have lasted only 6 hours. The planet has been quietly lengthening its own hours ever since. And here is the quiet thing to carry into sleep. The day you are living right now. This particular arrangement of morning and afternoon and evening and night, this length of darkness available to you for rest, is slightly longer than the day lived by any creature that came before you. Time, even in its smallest local units, has been slowly, gently, giving you more. The Moon does not only move the oceans. Everyone learns about tides early, the way the sea rises and falls in response to the Moon's gravitational pull, the way coastlines that once stood dry are briefly submerged and then reclaimed. It is one of the first pieces of physics that feels genuinely alive, genuinely personal, a reminder that the body of water covering most of the Earth is in a constant, gentle conversation with the body of rock circling above it. But the Moon does something else, something slower, something that operates not on the scale of hours, but on the scale of geological epochs. The tidal bulge the Moon raises in the Earth's oceans lags slightly behind the Moon's position as the Earth rotates beneath it. This lag creates a tiny gravitational friction, a resistance. The ocean's bulge pulls back on the Moon very slightly, and in doing so, transfers a small amount of rotational energy from the Earth to the Moon, slowing the Earth's spin by a tiny, accumulated, irreversible amount. Tidal forces from the Moon are the gentle brakes pulling on the Earth's spin, stretching our days across deep time. The Moon is not only a light in the night sky, it is, in its patient and ancient way, the mechanism by which darkness is gradually given more room. And you, resting in the dark right now, are the beneficiary of billions of years of that quiet transaction between a planet and its companion. There was a day, somewhere in the deep past of this planet, that lasted only a handful of hours. Not a short day in the way a winter day feels short, gone before the light had a chance to fully warm the ground. A physically, rotationally shorter day. A day that began at sunrise and arrived at sunset in less time than it now takes to watch a long film. When the Earth was young, perhaps in the first billion years of its existence, it was spinning faster, much faster. The collision that formed the Moon had transferred enormous angular momentum into the system, and the young planet was turning with an energy it would spend the next several billion years slowly releasing. Once, A day on Earth lasted only about 6 hours. The planet has been quietly lengthening its own days ever since, stretched by the same tidal friction that still works today, that will still be working long after any clock built by human hands has turned to dust. The sky would have looked different then. The sun rising and setting 4 times in what we would now call a single day. The stars wheeling faster overhead. The moon, closer and larger, pulling with greater force on seas that were still finding their chemistry. And through all of it, time moved at its local rate, unhurried by the planet's spin, indifferent to how quickly the light cycled from one horizon to the other. The universe does not keep time by watching sunrises. It has its own methods, slower, vaster, and far more patient than anything a spinning rock has to offer. There is a room inside a research facility somewhere on Earth. The room is precisely temperature-controlled. The equipment inside it is isolated from vibration by systems more sensitive than anything in ordinary engineering. The scientists who work there speak quietly without quite knowing why, as if loudness itself might disturb what they are measuring. Inside that room, particles are accelerated to speeds, approaching the speed of light, then released into a circular track and observed. And what those particles do, measured against what they should do if time were uniform and fixed, is the clearest possible proof that time is neither. Time, for a particle moving at nearly the speed of light, can slow to almost nothing, verified in particle accelerators built by human hands. The particles live longer than they should. They decay more slowly. They persist beyond the point where their own physics says they ought to have vanished, because from their perspective, barely any time has passed at all. This has been confirmed so many times, in so many facilities, with so many different types of particles, that it is no longer an experiment in the sense of testing whether something might be true. It is a demonstration, a calibration, a way of checking the instruments. Time dilation at the particle scale is now so well established that when results don't show it, physicists look for what went wrong with the equipment. And you, made entirely of particles, are subject to the same rules as every particle in that room. The physics doesn't stop at a certain size. It simply becomes too small to notice from the inside. You are, in the most literal sense, a collection of particles for whom time is a flexible and negotiable thing. You simply move slowly enough that the negotiation happens too quietly to hear. There are people who have looked up at the night sky with the particular kind of longing that comes not from wanting to go there, but from wanting to know what is happening there right now. And the answer, when it comes, is always the same gentle disappointment dressed as wonder. We cannot know. Not because our instruments are insufficient, not because the distances are merely inconvenient, but because the universe has a speed limit, and that speed limit is the speed of light, and no information of any kind can travel faster than that limit, which means that the further away something is, the older the news we receive from it. We have never detected a signal traveling backward through time, and the laws of physics, strangely, do not absolutely forbid it. They simply make it extraordinarily, perhaps infinitely, difficult. Every equation, every observation, every carefully designed experiment aimed at detecting information from the future has returned silence. And yet the equations, when pushed to their edges, do not slam shut with a definitive no. They grow complicated. They produce solutions that seem to allow for strange loops in time, for paths through space-time that curve back on themselves. They whisper possibilities that physicists take seriously enough to study and carefully enough to qualify. The universe has not yet handed us a clear answer. It has handed us an absence of evidence, which is not quite the same thing. And in that careful distinction, held lightly and without urgency, there is a kind of openness that the night is very good at holding. Some questions are not walls. They are doors left slightly ajar, letting in just enough light to see that the room beyond is larger than you imagined. In the mathematics of general relativity, Einstein's equations describe the relationship between the curvature of space-time and the matter and energy moving through it. They are among the most beautiful and most tested equations in all of physics. They work. Everywhere they have been applied, they have been confirmed. And within those equations, there exist solutions that describe something the universe may or may not actually contain, but which the mathematics permits with complete consistency. Closed time-like curves. A path through space-time that loops back on itself. A trajectory that, if followed long enough, would bring you back to a point you had already occupied, in a time you had already lived. Not metaphorically, geometrically. A curve in the fabric of space-time that closes like a ring rather than extending like a line. Some solutions to Einstein's equations allow for closed time-like curves, paths through space-time that loop back on themselves. Whether any such paths actually exist in the physical universe is unknown. The conditions required to produce them would involve configurations of matter and energy so extreme that we have no evidence they exist anywhere we can observe. But the mathematics does not forbid them. It simply describes them as possibilities, the way a map might include a road that no one has yet traveled, marked with careful dotted lines, and a note that says the terrain here is uncertain. The universe may contain loops in time that we will never find, or it may not. What it definitely contains is the human capacity to ask the question and sit quietly with the not knowing, which is its own kind of loop, curiosity, returning again and again to the same open edge. For every kind of object in the universe, physics has discovered or proposed a kind of mirror image, an antiparticle for every particle, a corresponding symmetry hiding somewhere in the equations, suggesting that the universe is built around a kind of deep structural balance that it does not always reveal on the surface. And for a black hole, the mirror image has a name. A white hole, where a black hole is a region of space-time from which nothing, not matter, not light, not information of any kind, can escape. A white hole is the theoretical time reverse, a region that expels matter and energy rather than swallowing them. A place from which things can only emerge, and into which nothing can fall. No white hole has ever been observed. There is no confirmed evidence that any white hole exists anywhere in the universe, but they are a valid solution to the same equations that correctly describe black holes. And some theorists have proposed that certain unexplained phenomena, including perhaps the origin of the universe itself, might be understood as something like a white hole event. The universe may have begun as something pouring outward from a kind of boundary, rather than simply exploding into pre-existing space. Time reversed, mirror imaged, running the other direction. And the fact that the mathematics allows for such a thing, even if nature has not chosen to build one, suggests that the universe keeps more options available than it actually uses, which is, in its way, a generous way to run a cosmos. There is an experiment at the heart of quantum mechanics that has troubled physicists for nearly a century and shows no sign of troubling them any less as time goes on. It involves particles so small that the word small no longer quite works. Particles at the scale where ordinary intuition stops functioning and the mathematics takes over, producing results that are correct and inexplicable in the same breath. When certain quantum particles are measured, they appear to have been in a definite state only from the moment of measurement, not before, as though the question, when asked, determines the answer rather than merely revealing it, as though the particle waited to decide until it was observed. And in some experiments, the setup seems to create situations where a particle's behavior in the present appears to depend on a choice that has not yet been made, where future decisions seem to reach backward into the past and influence what already happened. In quantum mechanics, some particles appear to behave as though they have knowledge of the future, a mystery that remains genuinely unsolved. Not a mystery in the sense that scientists suspect it will be cleared up with better equipment. A mystery in the sense that the best current understanding produces correct predictions and no satisfying explanation for why those predictions are correct. The universe, at its smallest scales, does not behave as though time runs only one way. It behaves as though the relationship between past and future is something more entangled, more reciprocal, more quietly strange than the arrow on a clock suggests. And you are made of particles that have been behaving this way, quietly and constantly, for as long as you have existed. Pour some cream into a dark cup of coffee. Watch it spiral outward, those pale ribbons curling through the dark, slowly losing their distinctness, spreading until the cup is a uniform, gentle tan, and the original swirl is nowhere to be found. Now imagine reversing that. Imagine the uniform tan gathering itself back into cream and coffee, the pale spiral reforming, retreating, until the two liquids are separate again, perfectly distinct, ready to be poured. You know immediately, without calculation, without physics, that the second version does not happen, that things mix and do not unmix, that order moves toward disorder, that the world runs in one direction when it comes to this particular kind of event, and that direction is not reversible. This tendency, the tendency of things to spread, to mix, to move from ordered arrangements into disordered ones, is called entropy, and it may be why time only runs in one direction. Entropy, the tendency of things to spread and disorder, may be why time has an arrow at all. The past is the direction of lower entropy. The future is the direction of higher entropy. And we experience time as flowing from one to the other because we are large, complex systems made of many parts that interact with the universe statistically, not one particle at a time. The arrow of time may not be written into the laws of physics at their most fundamental level. It may emerge from the statistics of enormous numbers of particles, all tending, on average, toward the most probable arrangement, which is to say, time may flow forward, not because the universe commands it, but simply because disorder is more common than order, and the universe, left to its own devices, tends toward the more common thing. The coffee mixes, the moments pass. Both are, in their way, the universe taking the path of least resistance. Imagine a room where nothing changes. Not slowly, not gradually, nothing at all. The air does not move. No particle shifts position. No photon crosses from one side to another. No chemical reaction proceeds. Nothing decays. Nothing forms. Nothing transitions from one state into another. In such a room, would time pass? The question sounds strange because such a room is physically impossible. Even a perfect vacuum in deep space is threaded with quantum fluctuations, virtual particles briefly flickering into and out of existence. True stillness, at the quantum level, is forbidden by the uncertainty principle. But the thought experiment points somewhere real, toward the relationship between time and change, toward the possibility that time is not a container that holds events, but something that emerges from events themselves. A perfectly isolated, perfectly ordered system would have no arrow of time. Past and future would be indistinguishable, not because time had stopped, but because there would be no way to tell which direction along the timeline you were traveling. Without change, the word before becomes meaningless. Without before, the idea of later collapses. And without later, time, in any sense that connects to experience, simply is not there. This suggests something both strange and intimate, that the passage of time you feel right now, the gentle drift from this moment toward the next, exists because things are changing, because your thoughts are moving, because your breath is shifting, because the world around you, even in its quietest version, is never entirely still. You are not experiencing time despite being alive. You are experiencing time because you are alive. The two are not separate. There is a number that appears in cosmology with a weight that ordinary numbers do not carry, not because it is large, though it is, not because it is precise, though it is measured with extraordinary care, but because of what it implies about the future, not of a single life or civilization, but of the universe itself, considered as a single object with a trajectory that extends far beyond any timescale human language was built to handle. The universe's expansion is accelerating, pushed by something called dark energy, a component of the universe that comprises roughly 68% of all that exists but remains, in terms of its fundamental nature, almost completely unknown. We observe its effects. We measure its influence on the expansion rate. We have given it a name. We do not know what it is. What we do know is that this acceleration will eventually stretch the universe across distances so vast that light from distant galaxies will no longer be able to reach us. Not because the galaxies are moving faster than light in any local sense, but because the space between us and them will be expanding faster than light can cross it. The universe's expansion is accelerating, pushed by dark energy, and this acceleration will eventually stretch time itself thin across unimaginable distances. The clocks will still be ticking everywhere, but the conversations between one region of the universe and another will gradually, over trillions of years, go quiet. Not with any drama, not with any announcement, simply with the slow, patient growing of distances that eventually become too great even for light to bridge. Far enough into the future, further than any number in common use can adequately represent, the universe will have changed in ways that make the word change itself feel insufficient. Stars will have burned out. The long, slow stellar night will have settled over most of the cosmos. Black holes, which outlast everything else, will themselves have begun the extraordinary slow process of evaporation through a mechanism first described by Stephen Hawking, radiating their mass away in quanta of thermal energy so slowly that a single black hole might take longer to evaporate than the current age of the universe, multiplied by itself many times over. And in this vast, cold, quiet future, something strange will be true about time. In perhaps 1 trillion years, isolated regions of the universe will each experience their own local time, disconnected from one another. Not because the physics changes, because the distances between them will have grown so large that no signal of any kind can cross from one region to another. Each island of remaining matter will exist in its own causal bubble, unable to communicate with any other, surrounded by an expanding void that light can never finish crossing. Each of those islands will have its own local now, its own local past and future, with no way to compare notes, no shared reference, no common clock to synchronize against. Time will not end. It will simply become entirely local, entirely private, each remaining pocket of the universe carrying its own moments in its own direction, with no one else to share them with. And somehow, knowing that this planet and this night and this quiet room represent a moment when the universe is still connected enough to be known, still young enough to be warm, still open enough to be wondered at, makes the present feel less ordinary and more like something worth being awake inside. Close to a rapidly spinning black hole, something happens to space-time that does not happen near a still one. It is not simply curved, it is dragged. A massive, spinning object does not merely bend the fabric of space-time around itself the way a heavy ball bends a rubber sheet. It twists that fabric. It pulls it around in the direction of its rotation. The way a finger dragged slowly through still water creates a swirl that extends outward from the point of contact, involving water that seemed uninvolved, drawing it into the motion. This effect is called frame dragging, and it is not theoretical. Time near a rapidly spinning black hole behaves differently than near a still one. Rotation drags space-time itself into a slow whirl around the spinning mass. The direction of time, the local flow of moments, is not merely slowed by gravity near such an object. It is also rotated, tilted, pulled around the axis of the spin in a way that has measurable consequences for anything moving through that region of space, including light, including the paths that orbiting objects take, including the ticking of any clock unfortunate enough to be caught in the vicinity. Frame dragging is extreme near a rapidly spinning black hole, but it happens everywhere a massive object spins, including here, including now. The Earth's rotation drags space-time around it, though by an amount so small it required one of the most precise satellites ever built to detect. Everything that spins is stirring time, and the universe is full of spinning things. In 2004, a satellite was launched into orbit carrying 4 of the most perfectly spherical objects ever manufactured by human hands. Quartz spheres, coated in a superconducting material, spinning inside a vacuum, isolated from every influence that might disturb their perfect rotation. They were the gyroscopes at the heart of an experiment called Gravity Probe B, designed to measure 2 predictions of general relativity that had never been directly confirmed. One of them was frame dragging, the gentle twist that the Earth's rotation imposes on the space-time around it. The Gravity Probe B satellite detected that Earth's spin gently twists the space-time around it, like a spoon stirring honey. The gyroscopes, over the course of a year in orbit, drifted from their original orientation by an amount consistent with Einstein's predictions, because the space-time they were spinning through was itself very slowly rotating around the Earth. The measurement was extraordinarily difficult. The drift being measured was smaller than the width of a human hair, viewed from 4 kilometers away. But the instruments were precise enough and patient enough, and the result was clear. The Earth is stirring time, gently, constantly, without effort or awareness. The planet you are resting on right now is not only holding you in its gravity, it is slowly, quietly drawing the fabric of space-time around itself like a blanket being turned in sleep. And somewhere in orbit, a set of perfect spheres once confirmed that this was true. Reach down, if you were to reach, toward the floor beneath you, and then consider your head resting where it rests, perhaps on a pillow, perhaps tilted toward the ceiling, some small distance above the ground. That distance, however modest, is enough. Enough for what, you might ask? Enough for the universe to treat your head and your feet as occupying meaningfully different positions in a gravitational field. Enough for time to move, by the most vanishingly small, but entirely real amount, at a different rate, at the top of your body than at the bottom. Your feet, closer to the Earth's center, sit deeper in the gravitational field. The fabric of space-time curves more sharply there, by the tiniest fraction. And so time, at your feet, moves the tiniest fraction more slowly than it does at your head. Even the mass of your own body curves space-time, pulling time ever so slightly slower at your feet than at your head. Not by any amount you could feel or measure without instruments of extraordinary precision, or that would add up to anything noticeable across an entire lifetime, but real. The same physics that bends time near a black hole, that slows the clocks of GPS satellites, that made Einstein's equations so difficult to accept and so impossible to refute, operates here, in this room, across the length of your resting body. You are not a single point in space-time. You are extended through it, and the universe, faithful to its own rules, treats every part of you according to exactly where that part happens to be. You are, in the most precise sense, a landscape, and time moves differently across your terrain. There is a laboratory in Boulder, Colorado, where scientists once placed 2 atomic clocks at different heights, separated by only 1 meter of vertical distance, and waited. 1 meter, roughly the length of your arm, a distance you cross without thought 100 times a day, a difference in height so ordinary that you would never pause to consider what it means for the local flow of time. They waited, and they compared, and the result was exactly what Einstein's equations predicted it would be, which is to say the result was real, and small, and quietly extraordinary. Scientists have confirmed time dilation using clocks separated by only 1 meter of height, and the difference was real. The lower clock ran slower, by an amount so small that expressing it requires scientific notation and a certain tolerance for numbers that arrive with many zeros before any significant digit. But the point is not the size of the difference. The point is that the difference exists at all, that the same gravitational time dilation that operates across the vast distances between a black hole's event horizon and the open space surrounding it also operates across the distance between a tabletop and the floor beneath. The universe does not apply its rules only at dramatic scales. It applies them everywhere, consistently, without exception, down to the smallest distances at which we have the instruments to look. The physics of stars and the physics of a quiet room are the same physics. The universe does not keep two sets of books. Every time you unlock your phone and a map loads, knowing where you are on the surface of the Earth to within a few meters, something is happening in the background of that transaction that most people will never think about. A correction is being applied. Satellites in orbit are transmitting precise timing signals. Your device receives those signals and uses the tiny differences in their arrival times to calculate your position. The math requires the timing to be extraordinarily accurate. A microsecond of error translates to hundreds of meters of positional inaccuracy. And the satellite's clocks, left uncorrected, would not be accurate. Not because of manufacturing flaws, because of physics. Because the satellites move fast, which slows their clocks via velocity-based time dilation, and because they orbit high above Earth's surface, where gravity is weaker, which speeds their clocks via gravitational time dilation. The two effects partially cancel, but not completely. The net result, without correction, would cause GPS systems to drift by roughly 11 kilometers per day. Time dilation is not a thought experiment. It is engineered into every GPS signal that guides a phone, a ship, or a search party. The engineers who designed GPS systems had to become, in a practical sense, applied relativists. They had to take Einstein's equations, written decades before satellites existed, and build their corrections into the system's architecture. Every time you find your way somewhere, you are benefiting from one of the most abstract physical theories ever conceived, made quietly practical, embedded invisibly into the infrastructure of daily life. Einstein imagined the universe. Engineers built it into your pocket. There is a question that seems simple until you press on it, and then it opens like a trapdoor into something much larger and darker and more interesting than the surface suggested. The question is, when did this happen? Not this specifically. Anything, any event, a flash of light in a distant galaxy, the moment two particles collide in an accelerator, the precise instant a clock reads exactly noon. For a single observer in a single place, the question has a clean answer. You were there. You saw it. It happened at a particular reading, on a particular clock. But for two observers moving relative to each other, the question becomes genuinely complicated. If the two events happen at the same moment for one observer, are they simultaneous for someone moving differently through space? The theory of special relativity emerged from a question about simultaneity. If two events happen at the same moment for one observer, are they simultaneous for another? And the answer, arrived at through careful reasoning and confirmed through precise measurement, is no. Two observers moving differently through space will disagree about whether two distant events happened at the same time, not because one of them made an error, not because the clocks were unsynchronized, but because simultaneity itself depends on the observer's motion. There is no view from nowhere that adjudicates the dispute. Both observers are correct within their own frame of reference, and a now that is shared by everyone, everywhere, all at once, is not something the universe offers. It never was. We simply believed it did, because, moving at the speeds of ordinary life, the disagreements are too small to notice. There is something deeply personal hidden inside a concept that sounds entirely abstract. Physicists call it the relativity of simultaneity. It means that two observers moving differently through space will never fully agree on what now means. Their present moments, if they are separated by distance and in relative motion, are genuinely different. Not differently labeled, different. But consider where that leaves you. Your now is here, in this room, in this body, in this particular arrangement of thoughts growing quieter as the night deepens. Your present moment is not shared with a distant galaxy, or a spacecraft, or even, in the most precise technical sense, with someone standing at a significant distance from you and moving at a different velocity. The present moment, in the deepest sense, may only exist locally, here, where you are, quietly breathing. Your now is the most real now available to you, not because you are at the center of anything, but because you are the observer, the one inside the frame of reference, the one for whom this particular arrangement of moments is the only arrangement of moments. There is something unexpectedly comforting in that. The universe does not offer a universal present, but it offers you yours, completely, without reservation. The entire weight of the present moment, however brief, belongs entirely to the experience of being in it, and you are in it now. Whatever else is true about time and space and the vast indifferent cosmos, that much is simply, quietly, entirely true. There is a theory, not yet confirmed, not yet falsified, sitting at the uncertain boundary between what physics knows and what it is still reaching toward, that proposes something about time so radical it makes the flexibility of Einstein's relativity seem almost conservative. What if time is not fundamental at all? What if it is something that emerges, the way heat emerges from the motion of particles, the way pressure emerges from the collective behavior of gas molecules, the way wetness emerges from water, even though no individual water molecule is wet? Some interpretations of quantum mechanics suggest that time is not fundamental, that it may emerge from something deeper, the way temperature emerges from the motion of particles. In this view, the most basic equations describing the universe would contain no time variable at all. Time would not be a dimension the universe exists within. It would be a pattern that appears when you look at the universe from the inside, when you are a large, complex, information processing system, like a brain, interacting with other large, complex systems in a universe of many parts. Time, in this picture, would be what the universe looks like to something living inside it, not what the universe is. This is not settled physics. It is an active area of genuine inquiry, pursued by serious people with serious mathematics. It may be wrong, it may be right, it may be pointing toward something whose full shape we do not yet have the language to describe, but it opens a space worth resting in. What if time, the most intimate of all your companions, the thing that carries every moment you have ever lived, is something the universe is generating for you, moment by moment, because you are here to receive it? Imagine trying to describe the universe not as a three-dimensional space in which things move forward through time, but as a four-dimensional object in which all moments, past, present, and future, exist simultaneously. No flow, no current, no movement from one moment to the next. Simply a vast, four-dimensional structure, like a sculpture or a landscape, containing every event that has ever occurred or will ever occur, all equally present, all equally real, all coexisting in a single static whole. This is the block universe, and it is not a fringe idea. It is the picture of reality that emerges most naturally from the mathematics of special relativity, and it is taken seriously by a significant number of physicists and philosophers who have thought carefully about what relativity implies. In loop quantum gravity, space and time are made of discrete, indivisible units, tiny pixels of reality too small to imagine. But in the block universe picture, time is not pixelated or flowing or emergent. It is simply there, all of it, at once. The moment of your first breath, somewhere in that structure. The moment of this night, somewhere else. The moment of your last day, already placed, already real, already existing alongside everything that came before it. In that picture, the moment of your birth and the stars you see tonight exist together in a vast, still, four-dimensional sculpture. The feeling of moving through time would be something that happens within the structure, the way a reader moves through a book that was always already complete. You may be traveling through something that has no traveler's entrance and no traveler's exit, only the traveling. There is a unit of time so small that describing it requires borrowing language from mathematics rather than from experience. The Planck time, named for Max Planck, the physicist whose work on the quantum nature of light set in motion a revolution in physics that has not yet fully settled. The Planck time is approximately 5.4 times 10 to the negative 44th seconds, which is to say, a decimal point, followed by 43 zeros, and then a 5. A duration so brief that compared to it, a single second is not merely long. It is cosmologically long. It is longer, relative to the Planck time, than the current age of the universe is relative to 1 second. The Planck time, the smallest meaningful unit of time, is so brief that compared to a single second, a second is like the entire age of the universe. At scales smaller than the Planck time, our current physical theories produce results that are infinite or undefined. The smooth, continuous fabric of space-time that general relativity describes may not be smooth at all at this scale. It may be granular, foamy, made of discrete units below which the concept of duration simply ceases to have meaning. We do not have a theory that works below the Planck scale. We have approaches, proposals, attempts. We have loop quantum gravity, string theory, causal set theory. We have serious people doing serious work in genuine uncertainty. What lies beneath the Planck time, if anything lies there at all, is not yet known, and the not knowing is a live frontier, not a closed door. The universe has not finished explaining itself. It is, in its own ancient and unhurried way, still talking. There is an idea in theoretical physics that sounds, at first encounter, like the premise of a science fiction story, but which emerges with complete mathematical consistency from some of the most carefully tested frameworks we have. The universe as a hologram. Not a hologram in the sense of a projected image or a decorative effect on a credit card. A hologram in the technical sense. A lower dimensional surface that contains enough information to fully describe a higher dimensional volume. Some theorists believe the universe is a kind of hologram, that what we experience as 3 dimensions of space and 1 of time is a projection from a simpler surface, that everything happening in the volume of the universe, every particle, every interaction, every moment of time, is encoded in a boundary surface of fewer dimensions, the way a 2-dimensional holographic plate can encode a 3-dimensional image. In this picture, time as we experience it would not be fundamental. It would be part of the projection, a feature of the volume, not of the boundary, something that emerges when the encoded information is read out into the space we inhabit. This idea, called the holographic principle, is not speculation in the pejorative sense. It is supported by precise mathematical results in string theory and has passed internal consistency checks that have convinced many serious physicists to take it seriously. Whether it is true is unknown. Whether it is the right framework is unknown. But the possibility that you are living inside a projection, that time is part of the picture rather than part of the screen, is a thought that the universe has not yet ruled out. And there is something almost restful about that. To be inside the image, entirely, warmly, completely inside it, with the light still falling softly all around. There is a question that sits at the very bottom of this entire subject, quieter than all the equations, simpler than all the theories, and in some ways more difficult to answer than any of them. Why does time have a direction? Not why does it flow exactly, not what it is made of or whether it is fundamental. Simply, why does it go this way and not the other? Why does the past feel fixed and the future feel open? Why can you remember yesterday and not tomorrow? Why does the universe, in all its complexity and strangeness, consistently produce a tomorrow that feels different in kind from a yesterday? The arrow of time, the reason why yesterday is fixed and tomorrow is open, is still one of the deepest unsolved questions in all of physics. The fundamental equations of physics, the ones describing how particles interact, how forces operate, how fields evolve, are almost entirely symmetric with respect to time. Run them forward and they work. Run them backward and they still work. The mathematics does not know which direction is future and which is past. And yet you know immediately, without calculation, without effort. Yesterday is closed, tomorrow is open. The difference is so obvious from the inside that it barely registers as a question. But the universe, at its most fundamental level, does not seem to know the difference. The arrow is not written into the deepest laws. It emerges somewhere, somehow, from the interaction of those laws with the particular state the universe happens to be in. Where exactly it emerges, and why, is something physics is still, quietly and persistently, working on. The universe keeps its deepest habits close, but it does not keep them perfectly hidden, and the people looking are patient and careful and awake. There is a particular kind of morning that most people have experienced at least once, the kind where you open your eyes, and for a brief, suspended moment, you do not know where you are, or what day it is, or how long you have been asleep. Everything is present tense. Everything is immediate. The past has not yet assembled itself around you, and the future has not yet made its demands. There is only the sensation of being awake, in a room, in a body, in a moment that has not yet been labeled. And then memory arrives. And with memory, the sense of time. Yesterday assembles itself. The day ahead begins to take shape. The arrow reappears, pointing in its familiar direction, and you are once again inside the flow. Memory itself gives you a sense of time's arrow. You remember yesterday, not tomorrow, because information about the past is physically recorded in your body and the world around you. The neural pathways that encode experience are altered by what has happened, not by what has not yet happened. The past leaves traces. The future leaves none. Your memory is not merely a record of time. It is part of what makes time feel directional. Without memory, past and future would be indistinguishable, the way they are in those few suspended seconds between sleep and waking, when the arrow has not yet found you again. And so the experience of time, so intimate, so constant, so fundamental to every moment of being alive, depends in part on the physical fact of memory, on the way experience reshapes matter, on the universe's tendency to leave marks. You are, in part, made of the past, and the past, in part, is what makes the present feel like now. Right now, in this moment, light is arriving at your closed eyelids. Photons from whatever source of light exists in your room, however dim, pressing gently against the darkness of rest. And each of those photons has been traveling, not far, in most cases. Across a room is nothing on a cosmic scale, but the principle embedded in that short journey applies equally to the longest journey light makes in the universe, from a source billions of light years distant to the instrument or eye that finally receives it. Every photon carries inside it the moment it was created. It left its source at a specific instant, in a specific state, encoding information about the conditions at its point of origin. And when it arrives, when it is finally absorbed, it delivers that information, a message from a past moment, carried at the only speed the universe allows for such messages. Even light carries time inside it. A photon absorbed by your eye carries information from a moment that has already passed. This is not a metaphor for something more abstract. It is physically, literally true. The photon that reaches your eye from a candle across the room left that candle a tiny fraction of a second ago. The photon that reaches a telescope from a distant quasar left its source billions of years ago. Both are carrying the past forward, delivering it to the present with perfect fidelity. You have never received information from the future. No one has. Every signal that has ever reached any receiver in the history of the universe has been a signal from the past, traveling forward, arriving exactly when the journey is complete. The universe communicates only in past tense, and somehow all of its messages still feel immediate. On a clear night, far from the wash of city lights, you can see with your own unaided eyes approximately 2,000 to 5,000 stars, depending on the darkness of your sky and the patience of your looking. Each of those stars exists at a different distance, which means each of those stars exists at a different depth of the past. The nearest star system beyond our Sun, Alpha Centauri, is about 4.3 light-years away. The light you see from it tonight is 4.3 years old. A bright star like Vega is 25 light-years away. Deneb, which appears comparably bright in the northern sky, is somewhere between 1,400 and 2,600 light-years distant. Its exact distance still uncertain. The stars you see with your naked eye exist at different depths of the past, some as they were decades ago, others as they were thousands of years before you were born. The night sky is not a flat backdrop. It is a record, a layered archive of different moments in cosmic history, all appearing simultaneously to your eye, because light from all of them is arriving at this particular place, at this particular instant. You are looking at a composite photograph made of moments from radically different eras, assembled by coincidence of distance and speed into something that appears unified and still. The sky is not still. It is ancient and layered and full of different pasts arriving together. And the fact that it looks peaceful, that it rests above you like something complete and settled, is one of the most beautiful illusions the universe quietly maintains for anyone willing to lie down and look up. There are stars so distant that the light reaching our instruments tonight has been traveling longer than the Earth has existed. The Earth formed approximately 4.5 billion years ago. Some of the galaxies captured in the deepest images ever taken by our most powerful telescopes are so far away that their light left its source more than 13 billion years ago, when the universe was less than 1 billion years old. The Earth was not yet a thought. The solar system was not yet a cloud of gas and dust beginning to collapse. And yet, the light traveled through the expansion of space, through the long dark between galaxy clusters, through epochs of cosmic history so different from the present that the universe today would be barely recognizable to itself as it was then. The light from the most distant galaxies the James Webb Space Telescope has captured left its source when the universe was less than 1 billion years old. A message in a bottle from almost the very beginning, and that telescope, floating in space at a point 1.5 million kilometers from Earth, received it, focused it, turned it into an image that can be looked at by a person lying in a warm room on a quiet night. The moment those ancient photons meet your eyes through an image on a screen, 2 moments in time, the universe's infancy and your tonight are gently touching, separated by nearly the entire length of cosmic history, connected by a single unbroken thread of light that refused to stop traveling. That connection did not require your permission. It was always going to arrive exactly here. There is a window, not a physical one, though you might look through a physical one to see it most clearly on a clear night. A window in time, a particular era in cosmic history defined not by human events but by the conditions necessary for the existence of anything complicated enough to look up and wonder. Stars must exist to forge the elements. Elements must exist to form planets. Planets must exist long enough and stably enough for chemistry to organize itself into something that replicates and evolves. Evolution must proceed long enough to produce nervous systems capable of asking questions. All of this requires time, billions of years of it. It also requires the universe to be young enough that stars are still burning, still making light and heat available for the slow, patient work of chemistry and biology. You exist at an extraordinary moment in cosmic time, after the first stars have lived and died, but before the universe has grown too cold and dark for life. The window is open. The stars are still burning. The elements necessary for your existence have been forged and distributed. The conditions are, right now, in this era, favorable. This will not always be true. In the deep future, the last stars will exhaust their fuel. The window will close. Not soon, by any human measure. But the universe has a direction, and the direction is gradually toward greater cold and greater dark. You are here during the light, and the light, while it lasts, is genuinely, completely, and without any need for embellishment, extraordinary. There is something the universe did not have to do. It did not have to produce complexity. It could have remained a hot, uniform gas expanding into itself. never allowing gravity to gather matter into stars, never allowing stars to forge elements, never allowing elements to combine into molecules, never allowing molecules to organize into the elaborate, fragile, astonishing structures that look at their own hands and find them interesting. It could have been simple. It chose, if that word can be stretched to apply to a universe, not to be. And among all the complex things the universe eventually produced, there is one that stands in a particular relationship to the subject of time, a thing that not only exists within time, but notices that it exists within time, that asks questions about time, that feels time passing, that lies in a dark room and wonders what time fundamentally is. Time does not require a witness to pass. Galaxies age in the dark, stars exhaust themselves in silence, and yet something in the universe has arranged for witnesses to exist. You are one of them, not by necessity, not by cosmic plan, as far as we can confirm, simply by the extraordinary improbability of everything working out in a way that allowed for something like you to be here tonight. The universe is very old. Most of it has passed without anyone inside it doing what you are doing right now. The brief, local, extraordinarily unlikely phenomenon of a mind turning toward the cosmos and simply paying attention is not something the universe requires. It simply, quietly, happens. And the happening is enough. Consider the sequence that produced this moment. A universe began. It expanded and cooled. Gravity gathered hydrogen into clouds, and clouds collapsed into stars, and stars burned for millions of years, and then died in explosions that scattered their contents across the growing dark. Those contents, carbon and oxygen and iron and all the rest, drifted through space for millions more years, until new clouds formed and new stars ignited, and some of those stars had planets around them. On at least one of those planets, conditions were right for liquid water to persist on the surface. In that water, chemistry organized itself into structures that could copy themselves. Those structures evolved over billions of years into something enormously more complex. And eventually, after all of that, after all of the deep and ordinary and unrepeatable time that it required, something sat in a quiet room and breathed and thought about how old everything was. The fact that you can wonder about time is itself a product of time, of billions of years of matter slowly learning to reflect on itself. Your capacity to ask the question is not separate from the answer. It is part of the answer. The universe wondering about time is the universe, through you, bending back on itself in the most intimate way possible. You are not outside looking in. You are the looking. You are what time made when it had long enough and the right conditions and, perhaps, something like patience. And the looking, tonight, is gentle and slow and asking nothing of you except that you remain here a little longer. There is a concept in physics called a singularity, a point at which the equations that normally describe the universe quietly stop working, where the values they produce become infinite, or undefined, or simply cease to correspond to anything that can be physically interpreted. Black holes contain singularities at their centers. The Big Bang is thought to have begun from a state that resembles a singularity. At these points, space-time curvature becomes infinite, density becomes infinite, and the smooth, continuous fabric of space and time that general relativity describes tears or dissolves into something the theory cannot follow. At the Planck scale, our ordinary understanding of time dissolves into something physicists do not yet have words for. Not because the people looking are not clever enough, because the framework that currently describes time, the one that has passed every experimental test we have been able to design, simply does not extend to those scales. It is not wrong at the scales where it has been tested. It is incomplete at scales it has not yet been tested on. And this incompleteness is not a failure. It is a signpost. It marks the edge of the known and points toward the unknown with the particular kind of precision that only good science can offer. Here is where we know. Here is where we do not. Here is the exact boundary between them. The universe keeps a room locked. And the scientists who care most about time spend their careers trying different keys, not impatiently, not urgently, with the quiet persistence of people who believe the room exists and contains something worth the wait. There is a library. Imagine it as you need to, old and large, or small and warm, wherever your mind goes when the word library is offered as an invitation rather than a direction. In this library, every book is a solution to Einstein's equations. Most of them describe universes very much like this one. Familiar geometries, familiar behavior for light and matter and time. Stable, navigable, ordinary in the way that extraordinary things become ordinary once you have lived inside them long enough. But some of the books describe other things. Wormholes, bridges between distant regions of space-time, or perhaps between different moments in time, folding the fabric so that 2 points which are enormously far apart by any ordinary path are suddenly adjacent. Universes with different numbers of dimensions, spacetimes with exotic topologies that loop and twist in ways that have no analog in daily experience. In that library, some solutions to Einstein's equations allow for closed time-like curves, paths through spacetime that loop back on themselves, and they sit on the shelf alongside all the others. Not highlighted, not specially marked, just there, mathematically consistent, physically unconfirmed, waiting. Whether any of those exotic books correspond to rooms that actually exist in the universe is a question observation has not yet answered. The universe has not said yes. It has also not said no. It has said, as it often does at these edges, something closer to, keep looking, and the looking, unhurried and patient and open, continues. Carried forward by people who found, early in their lives, that questions were better company than certainties, and who have been content with that company ever since. You are lying still, or nearly still. Your breath is slow. The world outside this room is doing whatever it does at this hour, and none of it is asking anything of you. And yet, at this moment, inside you, something ancient is keeping time. Your circadian rhythm is a biological clock tuned over millions of years to the spin of the earth. It knows, without being told, roughly when morning comes and roughly when darkness deepens toward its middle. It adjusts your temperature, your hormone levels, the readiness of your immune system, the depth available to your sleep. It does this not by consulting a clock on the wall, but by reading the chemistry of your own cells, which in turn are reading signals that stretch back millions of years to the rhythms of the turning planet. You carry the Earth's rotation inside you. The same force that has been gradually slowing the planet's spin across billions of years has shaped the timing of your body across millions of generations. You are entrained to a world in motion, synchronized to a rhythm larger than any individual life. And right now, as your circadian rhythm tells your body that this is the time for rest, that the chemistry of sleep is appropriate, that the signals say deepen and slow and let go, you are participating in one of the oldest conversations on this planet, between a living thing and the turning of the world it lives on. The planet is spinning you toward morning. It always has. And your body, ancient and faithful, is listening. Before there were animals with eyes, before there were nervous systems capable of registering the difference between day and night, before there was anything on this planet that could be said to experience time in any way resembling experience, something was already keeping track. Single-celled organisms, among the earliest forms of life this planet produced, carry within them molecular mechanisms that cycle on a roughly 24-hour rhythm, not because they learned this rhythm, not because they were taught it, but because the planet they arose on turns once every 24 hours, and the chemistry of survival rewards those whose internal cycles align with that turning. Even single-celled organisms have internal timekeeping. Life discovered clocks long before it discovered eyes, before vision, before hearing, before any of the senses we associate with awareness of the world. There was already a molecular conversation happening inside living things about what time it was and what the body should be doing in response. This means that timekeeping is not a sophisticated late addition to the story of life. It is not something that appeared when brains became complex enough to consult one. It is embedded in the very earliest chapters, in the chemistry of cells so simple they have no nucleus, in molecules cycling through states that match the turning of a planet that did not know it was being tracked. The clock in you is very old, older than your species, older than animals, older, perhaps, than almost anything you would recognize as familiar. It was running quietly inside the ancestors of everything alive today, keeping time in the dark, before there was anything to notice the dark at all. And tonight, that ancient clock is telling you, in the only language it has, that this is the hour for stillness, that the chemistry of rest is ready, that the rhythm, older than memory, is right on time. There is a forest. The trees are old, old enough that the rings inside them tell stories reaching back centuries. Each ring, a year. Each year, a complete cycle of season and growth, of warmth and cold, of the tree adding one thin layer of itself to all the layers that came before. Cut a cross-section of a very old tree, and you hold time in your hands. Not a representation of time, not a symbol or a metaphor. Actual, physical, encoded time. The year of a drought, marked as a thin ring. The year of abundant rain, marked as a wide one. A century of summers and winters, laid down in wood, patient and precise and available to anyone with the knowledge to read them. Trees record time in their rings. Corals record it in their skeletons. And ice cores hold the breath of atmospheres from hundreds of thousands of years ago. Pull an ice core from the deep Antarctic ice sheet, and you hold air from a world before humans existed, trapped in bubbles that formed when snow compressed into ice and sealed whatever atmosphere was present at that moment. The chemistry of that trapped air tells you the temperature, the carbon dioxide levels, the particular mixture of gases that surrounded the planet at that precise depth of time. The Earth keeps its own records. Long before humans invented writing or calendars or atomic clocks, the planet was encoding time into its own body, into its trees and its corals and its glaciers and its sediments and its stone. We are not the only ones who keep track. We are simply the most recent, and the planet's record is far longer than ours, and in many ways, far more patient. If you wanted to know the age of a rock, you would not ask it directly. Rocks do not speak, but they carry, locked inside their mineral structure, something that speaks for them with extraordinary precision. Certain elements decay. Over time, at rates so steady and so well characterized that they function as natural clocks, radioactive atoms transform into different atoms by shedding particles from their nuclei. Uranium becomes lead. Potassium becomes argon. Each transformation happens at a fixed rate, unaffected by temperature or pressure or chemistry, or anything the universe has thrown at it for the entirety of its existence. Uranium decays at a rate so steady that geologists use it to read the age of rocks going back 4 billion years, time written in stone, not estimated, calculated with precision. The ratio of uranium to lead in a sample tells you, with remarkable confidence, how long that sample has been sitting in its particular arrangement since it last melted and reset its radioactive clock. This is how we know the age of the Earth, not from any single measurement, but from the convergence of many measurements of many samples using many different decay systems, all agreeing with each other, all pointing to the same number, approximately 4.5 billion years. The planet is 4.5 billion years old. The rocks say so. The atoms say so. The steady, patient, indifferent tick of radioactive decay says so, in the only language that has never needed translation. Time is not only something we experience, it is something the universe writes down in every piece of matter that exists, continuously, without pause, in a script that chemistry can read. There is a method for reaching back into the human past that uses the same principle as uranium dating, but at a more intimate scale. A scale measured not in billions of years, but in tens of thousands. A scale that touches not the deep time of geology, but the shallower time of human presence on this planet. Living things, absorb carbon from their environment. A particular form of carbon, carbon-14, is radioactive. While an organism is alive, it continuously exchanges carbon with its surroundings, maintaining a ratio of carbon-14 to ordinary carbon-12 that reflects the ratio present in the atmosphere at that time. When the organism dies, the exchange stops. The carbon-14 it contains at the moment of death begins to decay at its steady, known rate, and the ratio of carbon-14 to carbon-12 begins to fall. Measure the ratio in an ancient sample, and you can calculate how long ago the exchange stopped, how long ago the organism died. Radiocarbon dating has given archaeology a voice reaching back 50,000 years. Every ancient artifact is a frozen moment, thawed by physics, a piece of charcoal from a prehistoric fire, a fragment of ancient cloth, a seed from a storage jar sealed in a collapsed building, each of them carrying inside their carbon atoms a clock that started at the moment they were last part of something alive. The past is not silent. It is full of stopped clocks, waiting for someone with the right instruments to read them. And when we do, the past speaks, quietly, precisely, with the complete absence of drama that comes from simply stating what happened and when. The dead carry time inside them, and the living have learned, slowly, carefully, to listen. There are questions that appear, at first encounter, to belong to philosophy. Questions about the nature of reality, about the meaning of existence, about why anything is the way it is rather than some other way. Questions that seem too large and too vague for the precise instruments of physical science to usefully address. And then a physicist sits down with the right equations, and the question turns out to have a physical face after all. Why is there time? Not what is time, not how does time work, but why does time exist at all? Why is the universe not simply a static, changeless structure, frozen in a single configuration, containing no sequence, no before or after, no passage from one state to the next? The presence of time may be inseparable from the presence of change, and the presence of change may be inseparable from the presence of something rather than nothing. A universe with content, a universe containing anything at all, may necessarily be a universe in which relationships between things evolve, in which the state of one thing depends on the state of another, in which sequence is built into the very fact of having parts that interact. Time, in this view, is not an addition to the universe. It is a consequence of the universe being a universe rather than nothing. It comes with the territory of existence itself, and if that is true, then time is not something imposed on the cosmos from outside. It is something that arises from within, from the bare fact of there being things, of things relating to other things, of relations having the capacity to change. You are not inside time the way a fish is inside a tank. You are inside time the way a conversation is inside language. The medium and the content are not separate. They arrive together, and they are, at their root, the same thing. There is a physicist, Albert Einstein, who said something about time that was not in any of his equations. Not a formula, not a derivation. A statement made, reportedly, in a letter written near the end of his life, to the family of a friend who had recently died. He wrote that the distinction between past, present, and future is only a stubborn illusion. Einstein reportedly said this and held the belief with quiet, deep conviction, not as a consolation, though it was offered in consolation, as a statement of what he believed the physics genuinely implied, that all moments are, in some sense, equally real, that the past is not less real for being past, that the future is not less real for being not yet arrived. That time's apparent flow is something that happens inside our experience of the universe, rather than something fundamental to the universe itself. He was not certain of this. The interpretation of relativity in these deepest terms remains a matter of genuine debate among physicists and philosophers, but he believed it, and he was a person who had thought about time more carefully than almost anyone who had ever lived. There is something worth carrying into sleep in that. The past has not vanished. The moments you have lived have not been erased. They exist. In whatever sense anything exists, with the same reality they possessed when they were the present. Your childhood, your first memory, your best and worst days, the moments that shaped you and the moments you have almost entirely forgotten. All of it, still, somewhere in the structure of what has been, not gone, simply no longer in front of you. There is a version of reality in which every moment that has ever occurred, and every moment that will ever occur, exists simultaneously in a single, vast, four-dimensional structure, the block universe. In this picture, time is not a flow, it is a dimension, just as space extends in three directions, and every point in space is equally real, regardless of whether you happen to be standing there. Time extends in its own direction, and every moment is equally real, regardless of whether you happen to be living through it. Time may be less like a river and more like a landscape. All of it there, all at once, with you simply moving through it. Your motion through time would be, in this picture, as real as your motion through space. You are not at a point in time. You are extended through time, the way you are extended through space, occupying a four-dimensional region rather than a single instant. The feeling of nowness, the particular quality of the present moment, the sense that this moment is alive in a way that yesterday is not, would be something happening inside your experience, rather than something written into the structure of reality. A feature of the view from inside, not a feature of the territory. This does not make the present feel less real. The view from inside is the only view you have. The feeling of being here, in this moment, in this room, in this body, is not diminished by the possibility that other moments are equally real, somewhere in a four-dimensional structure. If anything, it is deepened. Every moment you have ever lived was, at the time of its living, exactly as present as this one. They were all, every one of them, real. They are all, in whatever sense the block universe is true, still real now. There is a phenomenon so ordinary it barely registers as a phenomenon, and yet it points towards something in the physics of time that the equations alone do not quite capture. The feeling that time speeds up. Most adults recognize this. The years of childhood seemed vast. A summer lasted forever. An afternoon could contain an entire world. But somewhere in adulthood, the pace seems to shift. Years arrive and depart more quickly. A month passes in what feels like a week. The calendar moves faster than the interior experience of living seems to justify. The experience of time speeding up as you age may be because each new year is a smaller fraction of the total life you have already lived. To a 5-year-old, 1 year is 20% of everything they have ever experienced. To a 50-year-old, 1 year is 2%. The proportional weight of a year shrinks as the total accumulates, and so the felt duration, the subjective thickness of a year, may shrink with it. This is not physics in the sense of general relativity. It is psychology and neuroscience, and the particular way that human beings encode and retrieve and compress experience into memory. But it touches time nonetheless. It reveals that the time you experience is not simply the time the universe provides. It is something your mind constructs from the raw material of moments, shaped by what you know, what you remember, what you expect, and how old you are. You are not a passive receiver of time. You are, in part, its maker. And the making, tonight, is quiet and slow and taking its time. There is a practice, ancient in most of the world's traditions, and increasingly studied in modern neuroscience, that changes something measurable about the experience of time. Sitting still, attending to breath, releasing the pull toward past and future, and resting in the immediate sensation of the present moment. Meditation, or something like it. Something that has been practiced in different forms by different people for thousands of years, not always with the same name or the same philosophy, but with a recognizable common thread, the deliberate redirection of attention toward the present. Meditative stillness can genuinely alter your subjective experience of time. This is not metaphor, but a documented perceptual shift. People who meditate regularly report that time in meditation often feels both shorter and longer than it actually is. Shorter because the attention is absorbed and undistracted. Longer because each moment feels fuller, more present, more inhabited. Brain imaging studies show changes in regions associated with time perception during meditation. The default mode network, which is associated with mind wandering and rumination about past and future, quiets. The present tense becomes more available. And what is offered, in that quieting, is something the physics of the cosmos confirms in its own way, that the present moment is the only location where anything is actually happening. The past is memory. The future is anticipation. The present is where existence occurs. You are practicing something like that right now. Not formally, not intentionally, perhaps, but by lying still and letting the thoughts slow and the breath deepen. You are doing what meditators have always done. You are arriving at now. And now, as it turns out, is exactly where you needed to be. There is a version of time that you visit every night and from which you return without memory of the journey, without any account of where you were or what, if anything, occurred there. Sleep. Not the dreaming parts, which have their own relationship with time, their own way of compressing and expanding and rearranging sequence into something that follows dream logic rather than clock logic. But the deeper parts, the slow-wave sleep, the dreamless intervals, the periods of genuine unconsciousness in which the brain is doing its most essential maintenance work, and the experience of duration simply stops. Sleep collapses your experience of time entirely. Hours pass as nothing, and yet something in you continues, processing, restoring, quietly dreaming. The brain consolidates memory, clears metabolic waste, regulates systems throughout the body. The immune system works. The body repairs tissue. Growth hormone is released. Everything that needs a quiet interval to function uses the interval that sleep provides. And you, the experiencing part of you, the part that asks questions about time and wonders at the strangeness of the cosmos, is simply absent during much of this. Not gone in any permanent sense, simply switched into a mode that does not require or produce the experience of time passing. You cross hours of your life every night without any experience of their passing. You return from the crossing rested, renewed, with no memory of the darkness between. And the universe, during all of those hours, continued without requiring your awareness of it. The stars burned. The earth turned. The ancient molecular clocks in your cells kept their rhythm. Everything proceeded, faithfully and quietly, exactly as though you were watching, which is, in its own way, a kind of gift. The world does not need your attention to continue, and so you can let it go for a few hours and trust that it will be here when you return. It always is, somewhere in the deep past of this planet, in warm, shallow water, or perhaps in the chemistry of a hydrothermal vent on the ocean floor. Something began that had never happened before anywhere we know of. Matter organized itself into a structure that could copy itself. Not perfectly. The copies contained errors, and the errors, accumulating across generations beyond counting, produced variation. And variation, filtered by the slow, patient pressure of survival and reproduction across billions of years, produced everything alive on this planet today. Every bacterium, every tree, every insect navigating by polarized light, every whale moving through dark, cold water with a song no other species fully understands. And eventually, after all of that slow and unrepeatable accumulation, it produced something that could sit quietly in a dark room and think about the nature of time. Your circadian rhythm, that ancient biological clock, is only one example of how deeply time is written into the structure of living things. But the deeper truth is that every aspect of your biology reflects time. The particular shape of your immune system reflects the pathogens your ancestors survived. The particular wiring of your nervous system reflects the environments they navigated. You are, in every cell and system, a record of the time that produced you. Every heartbeat is a tick of a clock, calibrated not by machines but by billions of years of life, learning to keep rhythm with the world. Your heart does not beat at the rate it beats, by accident or by simple mechanical necessity. It beats at a rate shaped by the long history of what worked, what kept blood moving through bodies that needed to run, and rest, and survive the night, and wake to try again. Your heartbeat is ancient, and tonight, slowing towards sleep, it is keeping time the way it always has, faithfully, quietly, without needing to be told. There is a quality to the experience of time that resists every attempt to share it fully with another person. You can describe a moment. You can photograph it, record it, write about it with as much precision and care as language allows. You can tell someone exactly what happened and when and what it felt like, and they can understand your description, can even feel something in response to it. But they cannot have your moment. They cannot stand inside your particular experience of the seconds passing, the particular texture of your present, the exact weight of this night as it moves through you. The passage of time may be the most personal fact in the universe, experienced by everyone, fully shared with no one. Every conscious being that has ever existed has experienced time, has felt the present arriving and the past receding, has lived inside the movement from one moment to the next. This is perhaps the most universal of all experiences, the one thing every living thing with any experience at all has in common. And yet no two experiences of it are identical. Your now is yours. The particular quality of this moment, the specific arrangement of sensation and memory and anticipation, and the sound of your own breathing in a quiet room, belongs entirely to you. The universe offers time to everything equally, and everything receives it in a way that belongs entirely to itself. This is not loneliness. It is something more like intimacy, the universe handing you something that is, in the end, completely and only yours. A gift that cannot be shared because it was made specifically for the one receiving it, and you are receiving it now. Every second of it. There is a star that died before the Earth existed. Not one specific star, but many. Many generations of stars, in fact, that lived their full lives and exploded and scattered their contents into the expanding cloud of gas and dust that would eventually, after enough time and enough gravity, become the solar system, become the sun, become the planets, become, eventually, the particular arrangement of matter that includes this planet and everything on it. The carbon in your body was forged in the nuclear furnace of a star that no longer exists. The oxygen you are breathing right now was created in stellar interiors that burned out billions of years before your first breath. The iron at the center of your red blood cells, carrying oxygen through your body as you rest, was made in a supernova explosion so energetic that for a brief period it outshone the entire galaxy it inhabited. Even the atoms that compose you are ancient clocks, some of them forged in the hearts of stars that burned and died before the solar system existed, each atom carrying within it the particular configuration of protons and neutrons that was established in that long-ago stellar moment, and has remained unchanged since. You are not made of the universe's recent work. You are made of its deep past, of matter that has been through more than you can trace, that has existed in forms radically different from the form it currently occupies, that has traveled distances and spent time in arrangements that are entirely beyond reconstruction. The atoms in your body are older than the Earth. They are, some of them, older than the solar system. They were other things before they were you, and they will be other things after. But right now, in this arrangement, in this room, on this night, they are you. And that, in the long history of those atoms, is something genuinely new. The deepest archive on this planet is not a library or a server farm or any structure built by human hands. It is ice. In Antarctica, in Greenland, in the high mountain glaciers of ranges on every continent, ice has been accumulating layer by layer for hundreds of thousands of years. Each layer is a year. Each year contains, trapped in its structure, a sample of the atmosphere as it existed when that snow fell, and compressed into ice and sealed whatever it contained. Drill down through that ice, pull up a core, and you hold in your hands a continuous record of the Earth's atmosphere reaching back 800,000 years in Antarctica's oldest cores. Before the last ice age, before the one before that, before Homo sapiens had spread across the planet, before, in some cases, Homo sapiens existed at all. Ice cores hold the breath of atmospheres from hundreds of thousands of years ago. The carbon dioxide levels of a world humans had not yet significantly altered. The temperature signals of climates that cycled through ice ages and warm periods, on timescales longer than civilization. The volcanic ash layers marking eruptions whose sound, if anyone had been close enough to hear it, would have been extraordinary. All of it preserved, all of it readable, all of it waiting in the cold and the dark, until someone came with instruments sensitive enough to ask the right questions. The planet has been taking notes for far longer than we have, and its notes are detailed and patient and available to anyone willing to go somewhere cold and drill down far enough to listen. The universe is not silent about its own age. It speaks through its contents, its structure, its temperature, its composition, and the arrangement of everything within it. The ratio of hydrogen to helium throughout the universe tells a story about the conditions in the first few minutes after the Big Bang, when the universe was hot enough for nuclear fusion to occur and establish the basic elemental proportions that still characterize most of the matter in existence. The temperature of the cosmic microwave background, that faint ancient glow in every direction, tells a story about how much the universe has expanded since the light first escaped. The distances between galaxy clusters, the large-scale structure of the cosmos, tells a story about how long gravity has had to work, gathering and clustering and shaping matter into the web-like arrangement it currently inhabits. The universe itself is a kind of clock. The ratio of hydrogen to helium, the temperature of the background radiation, the distances between galaxies, all quietly marking how much time has passed since the beginning. Not a clock that anyone designed, not a clock that needs winding or maintenance. A clock built into the fabric of reality itself, ticking in the language of physics, readable by anyone with the patience and the instruments and the mathematical fluency to hear it. And what it tells us, consistently, across all of these different measurements, using all of these different methods, is that approximately 13.8 billion years have passed since it all began. The universe knows how old it is. It has been keeping track all along, in every atom and every photon and every relationship between everything and every other thing. It simply waited until something inside it was curious enough to ask. There is a question that philosophy has carried for a very long time, passed from thinker to thinker across centuries, arriving in each new era slightly worn from the journey, but no less alive for the wearing. Why is there something rather than nothing? Not how did the something arise, not what caused the something, but why, at the most fundamental level, does existence exist? Why is the default condition of reality fullness rather than emptiness? Why is there a universe at all? Time's deepest mystery may be this. Why is there time at all? Why not a static, changeless universe, frozen in a single instant? A universe with content, but no sequence, with matter, but no motion, with existence but no becoming. Physics does not yet have a clean answer. It has approaches, it has frameworks in which the question becomes slightly more tractable, slightly more amenable to mathematical treatment. But it does not have the kind of answer that you could write on one side of a small card and hand to someone who would then feel that the matter was settled. What it does have is the question itself, clear and patient, and genuinely open, sitting at the center of the deepest inquiry human beings have ever undertaken. And tonight, in the dark, in the quiet, in the particular stillness that comes just before sleep, you are closer to that question than most people allow themselves to be most of the time. Not because you have an answer, because you have the stillness to let the question exist without needing to resolve it. That is, in its own way, a kind of wisdom. to sit with what is not yet known, to let the open edge of things be open, and to find that the openness is not frightening. It is simply the shape of an honest universe, and it fits exactly the shape of a mind, willing to rest inside it. Some physicists dream of a theory that contains no time at all at its foundation, not a theory in which time is absent from the universe, but a theory in which time does not appear in the fundamental equations, in which the deepest description of reality is timeless, in which time, like temperature, is something that emerges at a higher level of description, something that appears when you zoom out from the fundamental to the collective, from the single particle to the system of many. In such a theory, time would arise only as something seen from the inside, by observers like you, not built into the bedrock, assembled by the act of observation itself, the way a face assembles itself from features that are individually not a face. This is not a settled conclusion. It is a direction of research, pursued by serious physicists working on quantum gravity, on the problem of time in quantum mechanics, on the relationship between thermodynamics and the arrow of time. It is a live question with live people working on it. But consider what it would mean if it were true. Time would not be something the universe does to you. It would be something you participate in producing. The experience of moments passing, of before and after, of this second being distinct from the last, would be something that arises at the boundary between a timeless fundamental reality and a sufficiently complex observer. You would not be inside time. You would be, in part, why time is here. Not you alone. Every sufficiently complex system that processes information and encodes history and exists in a state that depends on what came before would be participating in the same production. But you, specifically, in this room, on this night, breathing and thinking and noticing the passage of moments, would be part of what makes time real. The universe, looking at itself through you, would be the mechanism by which time arrives. There is a particular kind of relationship between two things that physics describes as entanglement. Two particles interact, and after the interaction, their properties are linked in a way that persists regardless of the distance between them. Measure one particle and the other, wherever it is, instantly takes on a corresponding state, not after a delay, not with any signal passing between them. Instantly, regardless of how far apart they are. This seems to violate the rule that nothing travels faster than light. But it does not, quite, because no information is transmitted by the entanglement. You cannot use it to send a message. You can only discover, after the fact, comparing notes, that the correlations were there. Entanglement has been confirmed in experiments. It is real, and some physicists believe it may be connected to the deepest structure of space-time itself, that the fabric of space, the connections between different regions of the universe, may be built from entanglement, rather than entanglement being built from space. In this view, you are not merely inside space and time. You are, along with everything else, part of the web of entanglement that constitutes space and time. Every particle in your body is entangled, in various ways, with the particles it has interacted with throughout its history, which means you are, in a real though not easily visualized sense, connected to the universe in ways that extend beyond your immediate location. You are not here and the universe out there. You are woven in. The connections are real, and they go further back than your memory and further outward than your skin. You have always been part of the fabric. You simply did not always have a word for it. There is a number that represents something almost too large to sit inside comfortably, and yet the sitting is worthwhile. The observable universe contains an estimated 2 trillion galaxies. Each galaxy contains, on average, hundreds of billions of stars. Many of those stars have planets. Some of those planets orbit in regions where liquid water could exist, and liquid water, as far as we currently understand, is one of the conditions that makes chemistry complex enough to eventually produce something that notices it exists. We do not know how many of those potential sites for life actually produced life. We do not know how many produce something like consciousness. We do not know whether the universe is full of minds, or whether ours is among a very small number, or whether it is in some sense alone. But we do know that the universe is very large, and we do know that it has been here for a very long time. And we do know that in this one confirmed case, in this one solar system, on this one planet, around this one star, in this one galaxy among 2 trillion, the matter of the universe organized itself into something capable of asking questions about time. The fact that you can wonder about time is a product of all of that, of the size of the universe and its age, and the particular path that matter took through billions of years of stellar evolution and planetary formation and biological complexity to arrive at a mind that finds questions interesting. You are not small because the universe is large. You are remarkable because the universe is large, and you are here anyway, thinking about it on a quiet night, with nothing required of you except that you rest. Whatever time ultimately is, whether it is a fundamental feature of reality or an emergent property, whether it flows or simply appears to flow, whether the past is gone or still real in some 4-dimensional sense, whether it had a beginning or whether beginning is a concept that only applies within time and not to time itself, one thing is available that none of the equations, for all their precision and beauty, can provide: the experience of it, the specific, immediate, irreplaceable sensation of being inside a moment, of this particular configuration of thought and sensation, and the quiet of a room at this hour, of breath, of the gradual softening of the mind towards sleep, of time, whatever it is, moving through you the way light moves through glass, changed by the passage, and changing what it passes through, and both the light and the glass somehow more themselves for the encounter. Whatever time ultimately is, you are living inside it, and it is moving gently through you, not as a metaphor, as the most literal, most immediate, most undeniable fact of this moment. You are in time. Time is in you. The relationship is so complete that there is no part of you that stands outside it, no corner of experience that time does not touch. And that completeness, that total immersion, is not a trap. It is the only place from which anything can be known, loved, remembered, or wondered at. You are not observing time from a distance. You are time, in one of its most intricate and temporary and quietly extraordinary forms, pausing to notice itself. And the noticing, tonight, is gentle and slow and very nearly done. There is a clock that no one built and no one tends and no one has ever held in their hands. It is running right now, in every direction, in every corner of the cosmos, in the cold between galaxies and in the hearts of stars and in the quiet interior of this room where you are resting. It is the clock of radioactive decay, of entropy increasing, of the slow, patient, irreversible movement of the universe from the extraordinarily ordered state it began in toward the more probable, more spread, more equalized state it is always moving toward. No clock anywhere in the universe ticks out a moment more valuable than this one, the one in which you are still and breathing and here, not because this moment is cosmically significant in the sense of altering the trajectory of galaxies, but because the universe has been running for 13.8 billion years in order to produce the conditions that make a moment like this one possible. The particular temperature of this planet, the particular chemistry of its atmosphere, the particular star it orbits, at the particular distance that allows water to be liquid and carbon to be complex, and life to be the kind of thing that lies in a dark room wondering about time. All of it required time. More time than the mind can fully absorb. The slow building of elements in stellar interiors, the distribution of those elements by stellar deaths, the gradual organization of a solar system, a planet, an ocean, a cell, a nervous system, a species, a language, a question. And here, at the end of all that preparation, a moment, quiet and unremarkable from the outside, irreplaceable from within. The universe spent an enormous amount of time making this moment available. The least you can do is rest inside it. There is something that happens at the edge of sleep that has interested philosophers and neuroscientists alike, a state that exists in the narrow passage between waking and unconsciousness, where the mind is still active enough to produce images and thoughts, but relaxed enough that the normal editorial function of waking cognition has begun to step back. The hypnagogic state, the threshold. In that threshold, time behaves strangely. A thought that occupies only a few seconds of clock time can feel much longer. A brief image can expand into something that feels narrative, extended, story-shaped. The mind, freed from the strict timekeeping of waking attention, begins to move through its own material according to a different clock. The experience of time speeding up as you age is one face of the relationship between time and attention. The hypnagogic state is another. In both cases, the lesson is the same. The time you experience is not simply the time the universe provides. It is shaped by the state of your nervous system, by what you are attending to, by how deeply you are engaged with the present, or how far your thoughts have drifted from it. Children experience time as vast and slow because every sensation is largely new. Novelty stretches the felt length of moments. Each new experience requires the mind to build a new model, to pay close attention, to process carefully. And careful attention expands time the way a slow breath expands the chest. Right now, at the edge of sleep, time may be doing something unusual, stretching, softening, losing its sharp edges, the boundary between one moment and the next growing less distinct. That is not time malfunctioning. That is time, the experienced kind, becoming more like what it may always have been at its root, fluid, patient, and in no particular hurry. There is a river in Eastern Africa where, for a few weeks each year, the water runs so clear that you can see individual stones on the riverbed from the surface, each stone worn smooth by the current. Each stone a record of the time it has spent in that particular conversation with moving water. The smoothness of a river stone is time made tactile. Hold one in your hand, and you are holding the record of years, perhaps centuries, of water and friction, and the slow, patient reshaping of one hard thing by another hard thing, working gently and without urgency in a direction that has no name but forward. The mystery of time is not something to be solved tonight. It is something to rest inside, gently, without urgency, the way a stone rests in a river. Not because the mystery is unimportant, not because the questions are not worth pursuing, but because some things reveal themselves more completely through patient inhabitation than through urgent investigation. The river does not explain itself to the stone. It simply moves around it, and the stone, over time, becomes rounder for the encounter. You have been in the river of time your entire life, every moment of it. The smooth places in you, the places where urgency has given way to something quieter, where certainty has given way to openness, where the hard edges have been worn into something more yielding, those are the places where time has had long enough to work. And the work is not finished. The river is still moving. You are still in it. And the stone, slowly, quietly, is still becoming rounder. That is enough for tonight. It is, in fact, more than enough. In the mountains of Central Asia, there are trees that have been alive for thousands of years. Not large trees, necessarily. In fact, some of the oldest living trees are small, gnarled, shaped by altitude and cold, into forms that suggest endurance more than abundance. Bristlecone pines, some of them, though they grow in other ranges too. Trees that were already old when the great ancient civilizations were young. These trees do not experience time the way you do. They have no nervous system, no memories in any recognizable sense, no experience of duration, and yet they are, in their own way, profound examples of persistence through time, of remaining, of continuing, slowly, through conditions that would challenge any simpler system. The oldest confirmed living tree on Earth is estimated to be over 5,000 years old. It was a seedling when the first writing systems were being developed on the other side of the world. It has grown through the entire span of recorded human history, adding its rings quietly and without commentary, turning sunlight into wood the way it always has, indifferent to everything that has happened in the centuries accumulating around it. Radiocarbon dating has given archaeology a voice reaching back 50,000 years, but the tree needs no instrument. It is its own record. Its rings are its autobiography, written in wood, in the language of seasons rather than words. Somewhere on this planet right now, in a cold, high place, that tree is doing what it has always done, growing or resting in winter dormancy, or moving sap through its ancient interior in the slow chemical conversation that has been its life for 5 millennia. Time passes around it, time passes through it, and it remains, quietly, without effort or awareness, simply by continuing to be what it is. There is something in that worth carrying into sleep. There are scientists who spend their careers looking at light that is more than 13 billion years old. They work with instruments of extraordinary sensitivity, calibrated to detect signals so faint that they are essentially at the threshold of what physics permits to be detected at all. They process data for months and years. They write papers that are read by small communities of specialists who understand, in detail, what the measurements mean and what they imply. And what the measurements reveal, consistently and with increasing precision, is the structure of the universe as it was in its infancy. The distribution of matter in the first moments after the universe became transparent to light. The seeds of the large-scale structure that gravity would spend billions of years amplifying into the web of galaxy clusters and cosmic voids that exists today. The cosmic microwave background, that ancient faint echo we encountered earlier in the night, is not uniform. It has tiny variations in temperature, fluctuations so small they were almost beyond detection, that encode information about the very earliest moments of the universe's existence. Those fluctuations are the ancestors of everything. The slight overdensities that gravity would amplify over billions of years into galaxy clusters. The slight underdensities that would become the great cosmic voids. The entire large-scale structure of the universe. Everything we see when we look at the deepest maps of the cosmos traces back to variations in the temperature of light that is now billions of years old. You are a descendant of those fluctuations. The particular arrangement of matter that produced your solar system, your planet, your existence, traces back through billions of years of cosmic evolution to slight unevennesses in the early universe that were smaller than anything in ordinary experience. The universe was not perfectly smooth at the beginning, and its imperfections, amplified by time, became everything. Including this, including now, including you. There is a word in Portuguese that does not translate cleanly into most other languages. Saudade. It describes something like longing, but not quite. Something like nostalgia, but not quite that either. A gentle ache for something loved that is absent. For a past moment, a lost place, a person no longer present. Not the sharp pain of grief. Something softer, more sustained. The emotional texture of time having passed and taken something with it. The existence of this word, the fact that a human community found it necessary to have a specific sound for this specific feeling, tells you something about the relationship between consciousness and time, about the way that beings who live in time develop not just thoughts about time but feelings about it, emotional textures that arise specifically from the experience of having a past that is real and irretrievable and still somehow present in the form of longing. The passage of time may be the most personal fact in the universe, and the emotions that arise from it, the love of particular moments, the grief of their passing, the warmth of memory, the gentle ache of saudade, are among the most specifically human responses to a condition that is entirely universal. Everything in the universe is subject to time. Only some things feel its passage, and of those, only some develop language to describe what the feeling is. You have that language. You have those feelings. You have the capacity to love a moment enough to miss it when it is gone. That capacity, is not a side effect of consciousness. It may be one of consciousness's most important features. It means the moments mattered. It means they were real enough to be mourned. And that is, in its quiet way, one of the most affirming things the universe has ever produced. There is a practice in Japanese aesthetics called mono no aware. It translates, roughly, as the pathos of things, the bittersweet awareness of impermanence, the beauty that arises specifically from the fact that things do not last. Cherry blossoms are the most familiar example. They bloom for only a week or two. Their briefness is not incidental to their beauty. It is the source of it. The awareness that the blossoms will fall, that the particular quality of this light through these petals on this specific morning will not recur in exactly this form, is what makes the looking so attentive, so tender, so fully present. The fact that you can wonder about time is a product of time itself, and the particular quality of wondering that arises from knowing that time passes, that moments are unrepeatable, that this night will not come again in exactly this form, is something that would not exist in a universe where moments were permanent. Impermanence is not the problem that beauty must overcome. Impermanence is part of what creates beauty in the first place. The stars are burning fuel they will eventually exhaust. The night is moving toward morning. The particular arrangement of your thoughts right now, in this exact state of drowsy openness, will not recur. And knowing this, even softly, even at the edge of sleep, makes the present moment more present, more inhabited, more itself. You are in a moment that will not repeat. The universe arranged for you to be here, in this configuration, with this awareness, on this specific turning of the planet. And the moment is brief. And the briefness is, in the oldest human traditions of finding meaning in existence, exactly what makes it worth attending to. There are scientists who study something called the fine-tuned universe. The observation that the fundamental constants of physics, the particular values of things like the strength of gravity, the mass of the electron, the rate at which the universe expanded in its earliest moments, appear to be set to values that allow for the existence of complexity. Change the strength of gravity slightly, and stars either burn out in seconds or never ignite. Change the mass of the electron slightly, and chemistry as we know it becomes impossible. Change the expansion rate of the early universe slightly, and it either collapses back on itself before stars form, or expands so fast that matter never gathers into anything. The values we observe happen to fall within the narrow range that allows for stars, planets, chemistry, life, and minds wondering about all of it. You exist at an extraordinary moment in cosmic time, but you also exist in a universe with extraordinary values for its fundamental constants. Whether this is a coincidence, a necessity, a feature of a multiverse in which all possible values are realized somewhere, or evidence of something else entirely, is not settled. What is settled is the observation itself. The universe is built in a way that permitted you. The constants were set, by whatever process set them, in a way that allowed time to be long enough, and matter to be complex enough, and conditions to be stable enough for something like you to eventually appear and notice the strangeness of your own appearance. The universe did not have to be this way. And it is. And you are here because it is. And tonight, resting in the warmth of a planet, orbiting a star that burns at exactly the right rate, in a universe with exactly the right constants available to rest inside, there is a moment that happens in the very deepest part of a clear night, when the last light on the horizon has finally gone and the eyes have fully adjusted, and the sky reveals itself in its full depth. Not a flat backdrop of points, a volume, a space extending outward in every direction, with some lights nearby, and some so far they barely register, with the band of the Milky Way cutting across it, like the glow of something enormous seen from very far inside it, which is exactly what it is. You are inside the galaxy, looking outward through its disk, seeing the combined light of hundreds of billions of stars compressed by distance into a soft, continuous glow. And beyond that glow, in the patches of dark between the stars, other galaxies, Other systems of hundreds of billions of stars, each too far to resolve individually, each appearing as a faint smear of ancient light. Every telescope is also a time machine. And the naked eye, in its own modest way, is a time machine too. The light reaching your eyes right now from the furthest stars visible without aid left its source before your ancestors had language. You are looking at the past, and the past, vast and layered and ancient beyond reckoning, is looking back at you through the only instruments it has available, the light it sent forward, traveling at the only speed it knew, arriving exactly here, exactly now, exactly when you happen to be watching. The universe aimed its oldest light at this moment, and you are in it. There is something the universe does not do, which is perhaps as interesting as everything it does. It does not forget, not in the sense of memory, exactly, not in the way a mind retains and recalls, but in the sense that information, the specific physical state of any system at any moment, is not simply erased by the passage of time. According to the deepest principles of quantum mechanics, information is conserved. It may be scrambled, redistributed, encoded across so many particles in such complex ways that it becomes practically inaccessible. But it is not gone. The past is, in this sense, still present in the current state of the universe. Not accessible, not reconstructible in any practical sense, not available to any instrument we could build, but there, encoded in the positions and states and entanglements of every particle that exists, is the record of every moment that led to this one. Every heartbeat is a tick of a clock that leaves a mark. Every breath alters the world slightly. Every photon that reaches your eye carries information that will be redistributed into the universe rather than annihilated. The past, in its most fundamental physical sense, is still here, dissolved into the present, encoded in the state of everything. You are not separate from the past. You are downstream of it, composed of it. Every atom in you was somewhere else before it was here, doing something else, being part of something else. And the record of all of that, however scrambled, is encoded in the current state of the universe. Nothing is truly lost. It is only redistributed, made unreadable, spread so wide that retrieval is impossible, but still there, quietly, always. There is a quality to the last hour before sleep that is unlike any other hour of the day. The body has begun its preparations. Temperature drops slightly at the core. The breath slows without being asked to. The muscles release tension they have been holding since morning, tension so habitual it went unnoticed until it began to leave. The mind grows softer at its edges, less insistent about the things it was certain of an hour ago. This is not failure. This is the body doing what 4 billion years of life on a spinning planet have taught it to do, preparing for the crossing into rest, handing the work of existing over to systems that do not require your participation. Even the atoms that compose you are ancient clocks, and right now, those atoms, those cells, those systems are reading the same signals they have always read: the darkness, the cooling, the quiet, the accumulation of small chemical changes that add up to the simple instruction, now rest. You did not invent sleep. You inherited it from every living thing that came before you, from the single-celled organisms keeping their 24-hour rhythms in ancient oceans, from the first animals that discovered the benefit of stillness, from every creature in the long line that leads to you, that found in the dark hours a necessary counterweight to the light ones. Sleep is one of life's oldest agreements with time, a recognition that the body needs intervals, that existence is not continuous in the way a river is continuous, but rhythmic, like a tide, filling and emptying, engaging and releasing, arriving and gently letting go. And right now, the tide is going out, gently, as it always has, as it always will. Consider the light from a candle. It spreads outward from its source in every direction, moving at the speed that all light moves, carrying information about the flame, its temperature, its color, the particular quality of its burning. 1 year from now, That light will have traveled approximately 9 trillion kilometers in every direction, a sphere of information, expanding. 10 years from now, 10 times larger. 1,000 years from now, a sphere of light originating from this candle will have passed through star systems, through the dark between them, still expanding, still carrying the faint encoded memory of this specific flame on this specific night. Your life emits something similar, not light exactly, but information. The physical record of your existence is encoded in every interaction you have with the world. Every breath you release alters the atmosphere by a quantity too small to measure, but not too small to be real. Every step you take redistributes matter. Every thought you have is a physical process that leaves a physical trace. The moment those ancient photons from distant galaxies meet the instruments that receive them, 2 moments in time touch. And in the same way, however faintly, however unreachably small, every moment of your existence touches the universe, leaves a mark, encodes itself in the state of everything downstream. You are not passing through the universe without effect. The universe is different for your having been in it. Not dramatically, not in ways that will be recorded or remembered, but physically, actually, in the only sense that the universe keeps records, which is in the state of itself. You are already written into the universe. You have been, every moment you have been alive. The James Webb Space Telescope floats right now, at this moment, at a gravitationally stable point in space called L2, 1.5 million kilometers from Earth, in the direction away from the Sun. It is cold there, extraordinarily cold, by design. Its instruments are kept at temperatures close to absolute zero, because the infrared light it is built to detect, the stretched and reddened light of the most ancient and distant galaxies, would be swamped by any warmth the telescope itself produced. And it looks, patiently, accumulating photons over hours and days of observation, building images from light so faint that individual photons arrive only occasionally, building, from that patience, pictures of the universe as it was in its earliest chapters. The light from the most distant galaxies Webb has captured left its source when the universe was less than 1 billion years old. And when that light finally arrives, after its journey of more than 13 billion years, it lands on an instrument built by human hands on a planet that did not exist when the journey began. There is something in that which the word remarkable does not quite reach. A species that has existed for perhaps 300,000 years, on a planet that has existed for 4.5 billion years, in a universe that has existed for 13.8 billion years, built a machine and sent it into space and used it to receive light that has been traveling since before the Earth existed. And they looked at what the light contained, and they understood some of it, and they wrote papers and shared images. And a person lying in a quiet room in the dark on an ordinary night learned that this had happened, and felt quietly and without urgency that it was one of the finest things a species had ever done. There is a concept in thermodynamics called the heat death of the universe. Far in the future, further than any number in common use can represent, the universe will have reached a state of maximum entropy. All the temperature differences that drive the processes of stars and chemistry and life will have equalized. There will be no more gradients, no more flows, no more possibility of useful work being done, because useful work requires a difference between hot and cold, between ordered and disordered, and in the heat death, all differences have been exhausted. Time will still pass. The clocks, if any existed to measure it, would still tick, but nothing would happen. Nothing could happen. The universe would be at rest in the most absolute sense, a vast, cold, dark, uniform expanse in which the concept of before and after would have no content, because nothing would be different from one moment to the next. And yet, between now and then, this window of warmth and light and complexity, this brief, cosmically brief, interval in which the universe is far from equilibrium, in which stars burn and planets orbit and oceans move and life exists and minds wander, This particular era, this few billion years in the middle of the universe's timeline, in which the conditions for everything interesting are not only present, but abundant. You are alive during the interesting part, not by accident of birth in any narrow sense, by the coincidence of existing in this era rather than the long cold silence that eventually follows it. The warmth around you right now, the warmth of the room, of the blanket, of your own body generating heat from the chemistry of being alive, is borrowed from a universe that is slowly, patiently cooling. And the borrowing is temporary, and the temporariness makes the warmth more itself. Rest in it. You are exactly where the universe is warmest and most alive and most awake to its own existence. There is a kind of knowing that is not knowledge in the usual sense, not facts accumulated, not understanding built through study or effort or the patient application of instruments to questions. Something quieter, something that arrives not when you pursue it, but when you stop. The kind of knowing that comes from simply being inside something long enough that you stop asking what it is and start feeling what it is like. You have been inside time your entire life. Every moment you have ever lived, every sensation you have ever had, every thought and dream and quiet interval before sleep, all of it has happened inside time. You have never been outside it. You have never observed it from a distance. You have only ever known it from within. And that knowing, whatever its limitations in the direction of precision and objectivity, is the most intimate knowing available. More intimate than any equation, more immediate than any measurement. The knowing that comes from being inside the thing itself, from having no alternative but to inhabit it completely, from carrying it in every cell and every heartbeat and every breath. Whatever time ultimately is, you are living inside it, and it is moving gently through you. And you know this the way you know the warmth of a particular room, or the particular quality of the quiet just before sleep, not because you can define it, because you are in it. And the being in it, unhurried and complete, is the only knowledge about time that was ever truly yours to have. Somewhere right now, in the dark between galaxies, a photon is traveling. It left its source billions of years ago. It has been traveling ever since, through expanding space, through the long dark between galaxy clusters, through the silence that space keeps so completely that no instrument built from within it can hear. It is not going anywhere in particular. It has no destination. It was released in a direction, and it has been moving in that direction ever since, at the only speed it knows, through a universe that has been expanding around it the entire time. It will travel for billions more years. It may never be absorbed by anything. It may simply continue, redshifting as the universe expands, losing energy so slowly that the loss is imperceptible across any timescale a human mind can hold, until it is so stretched and so faint that no instrument will ever detect it. And yet it exists, right now, somewhere in the dark between here and there. You are not that photon. You are warm and brief and rooted to a planet and moving through time at the pace that a body, moving through a gravitational field at this particular speed, moves through time, which is to say, at the full, unhurried, generous pace of an ordinary human night. And the photon is out there, and you are in here, and the universe contains both of you, the ancient traveler and the resting witness, without preferring one over the other, without ranking. The long, cold journey above the warm, still pause. Both are the universe, doing what the universe does, moving, resting, carrying on. There are things happening right now, quietly, while you rest. The earth is turning, not dramatically, not in any way you can feel in this moment of stillness, but turning nonetheless, carrying you from one position relative to the sun toward the next, moving the horizon toward morning at a rate so steady that you can set an expectation by it, and the expectation will be met. The moon, wherever it is in its current phase, is pulling on the oceans. The tidal bulge is tracking across the planet's surface, slowing the spin by the same tiny increment it has been applying for billions of years. The days are getting longer, by an amount too small to measure in a lifetime, but longer. The sun is fusing hydrogen into helium in its core, as it has been doing for 4.6 billion years, releasing energy that will take tens of thousands of years to work its way from the core to the surface, and then 8 minutes and 20 seconds to reach this planet and arrive as the light of a new morning. Somewhere in the upper atmosphere, muons are raining downward, slowing in their personal experience of time, surviving long enough to reach the ground, passing through the roof above you and through your body and continuing into the earth below. The cosmic microwave background is arriving from every direction, ancient and faint, the oldest light in the universe, still traveling, still arriving, still carrying its record of the universe's earliest transparency. All of this is happening right now, while you rest, while your breath slows and your thoughts soften and the night deepens around you. The universe does not pause for sleep. It continues, faithfully, in every direction, at every scale, in every language of physics it has ever spoken. And you, resting inside it, are part of that continuance. Your rest is not absence from the universe. It is one of the things the universe is currently doing. Somewhere, a star is being born. Somewhere, one is dying. Somewhere, a planet is crossing in front of its sun. Somewhere, two galaxies are beginning the long, slow gravitational conversation that will end billions of years from now in their merging. And here, in this room, a person is breathing, slowly, more slowly now, carried towards sleep by the oldest rhythm life knows. Both are real. Both are the universe, in this moment, being itself. You have traveled a long way tonight. From the bending of time near a black hole to the molecular clocks inside a cell. From the first moment of the universe to the moment just before sleep. From the largest scales the cosmos contains to the length of your own body, resting in a room on a planet that is quietly, faithfully turning. You have been inside questions that have no final answers. You have rested near the edges of what is known and looked out at what is not yet known and found that the edge was not a wall, but a horizon, and that horizons are not endings, but the place where the known opens into the possible. The mystery of time is not resolved tonight. It was never going to be. What was possible tonight was something different, and perhaps more useful for the hour. To feel the strangeness of time, not as a puzzle to be solved, but as the medium you live inside. To notice that you are, right now, in the only moment that is ever available to you, which is the present one. The past is real, the future is open, and here, between them, is the only place that existence actually occurs, the only place where anything is felt, or known, or loved, or wondered at. Here, where you are, right now, breathing, resting, held by a planet, warmed by a star that burned its light 8 minutes ago and sent it here as a gift to a morning you have not yet seen. The universe is very old. You are briefly here, and your being here, this brief and improbable and quietly extraordinary arrangement of matter that has the capacity to feel the passage of time and find it worth attending to, is one of the things the universe is doing with itself in this particular era, in this particular corner, on this particular night. You are not small because the universe is vast. You are what the universe grew over 13.8 billion years in order to have something capable of noticing its own vastness. And tonight, that noticing is soft and slow and drawing towards stillness. Let the breath come and go without direction. Let the thoughts arrive and drift without the need to follow them anywhere. The clocks are still ticking somewhere. The GPS satellites are sending their corrected signals through the dark. The muons are still falling. The ancient light is still arriving from every direction. The earth is still turning, gently, toward morning. And you are still here. For a little while longer, in the warmest and most alive era the universe has yet produced, in a body that knows, without being told, that this is the hour for rest. Time will continue after you sleep. It always does. The moments will accumulate without your awareness of them, the way they always do in the deep hours. and you will return to them, rested, in a morning that the sun has already sent its light toward, that light already traveling, already on its way, already 8 minutes into its journey to reach you where you will be. The universe is not asking anything of you right now. The questions can rest, the wondering can soften, the vast and beautiful strangeness of time, of space, of the improbable fact of existence will still be here tomorrow, patient, open, waiting for the next curious mind to sit with it in the dark. For now, only this: the room, the quiet, the breath, the ancient rhythm of a body that has always known when to rest, the long, slow, generous night, holding you the way the universe holds everything that exists within it, without effort, without condition, without asking anything in return except that you simply continue to be here. And you are here, still, and breathing, and here. I hope you sleep well and dream softly. Good night.